Hi, everyone. Welcome to session 3 of the Great Lakes Coastal Wetlands webinar series hosted by Environment and Climate Change Canada and Toronto and Region Conservation Authority. My name is Sharon Lamb, and it is my pleasure to moderate today's webinar. I'm a project manager with the Ecosystem and Climate Science team at Toronto and Region Conservation Authority, and I'm joined by an amazing group of colleagues in both ECCC and TRCA, some of whom you'll meet over the course of this afternoon. Let me begin by taking a moment to respectfully acknowledge that all of us at this virtual meeting, no matter where we are located on land that has been home to Indigenous nations since time immemorial. We respectfully acknowledge that the lands we are situated on are traditional territories and treaty lands, in particular those of the Mississaugas of the Credit, the Anishinaabeg of the Williams Treaty First Nations, the Huron-Wendat, the Haudenosaunee, and are now home to many diverse First Nations, Inuit, and Métis peoples. We appreciate and respect the history and diversity of the land and are grateful to have the opportunity to work and meet in this territory. And we are honored to be joined by representatives of Indigenous organizations at today's webinar and at our previous sessions. Let's now go over some quick housekeeping notes. Today's session is being recorded, and a copy of the recording and slides will be shared with all of you in a couple of weeks following the completion of the webinar series. All participants are muted and video disabled to minimize disruption and save bandwidth and emissions. Please use the Q&A box at the bottom of your Zoom control panel to post questions throughout today's session. You can also upvote others' questions in the Q&A. To share comments, please use the chat, and thank you to all of you for sharing with us in the chat your name and where you're calling from today. It's great to see some familiar names. Closed captioning is available in English, and you can enable or disable this by clicking the CC icon at the bottom of your Zoom control panel. If you encounter any technical issues with Zoom, please send an email to Jessica for support. And with that, let's now take a look at what we have already covered and what we still have planned for you over this week-long 5-part webinar series. The first 2 webinars on Monday and Tuesday focused on the results of Environment and Climate Change Canada's Great Lakes Coastal Wetlands Climate Change Vulnerability Assessment. Session 1 was focused on the results of the climate, lake level, and wetland response modeling developed by Environment and Climate Change Canada. And Session 2 yesterday focused on the remaining results from the vulnerability assessment, including wetland sensitivity, adaptive capacity, and overall vulnerability. If you missed these 2 sessions, we do hope that you'll check out the recordings once they are available in a couple of weeks. Over the course of sessions 3 to 5 from today until Friday, we will explore different climate change adaptation strategies and options to enhance the resilience of Great Lakes coastal wetlands, with guest speakers from across the Great Lakes Basin. Today's session will focus on reducing non-climatic stressors such as land use change, enhancing adaptive capacity, and protecting littoral cell geodiversity and barrier landforms. Jessica has shared a link to the detailed agenda in the chat, and hopefully you'll be able to join us for these upcoming sessions as well. Through these webinars, we hope to engage coastal wetland practitioners, describe Environment and Climate Change Canada's vulnerability assessment modeling and analysis, share the results of the climate and water level projections, wetland sensitivity, adaptive capacity, and vulnerability, and explore best adaptation strategies and options to enhance coastal wetland resilience. With that, let's now take a closer look at what we have in store for you today. We'll begin with a presentation by Greg Main and Anders Holder, who will provide an overview of Environment and Climate Change Canada's white paper on solutions to enhance Great Lakes coastal wetland resilience, which was prepared as part of the Assessing and Enhancing the Resilience of Great Lakes Coastal Wetlands project. Greg and Anders' presentation will help set the stage for our 5 exciting guest presentations today, starting with the rural context with Laura Ellis, who will speak about ALICE, a program to restore wetlands and associated natural features on farmland in the Great Lakes region. We will then move on to the urban context with Ralph Tonninger, who will share with us 30 years of lessons learned from coastal wetland restoration and adaptive management along the shores of Lake Ontario in Canada's largest city. We will then take a quick 5-minute break and come back for part 2, starting with Paul Biscaya, who will speak to us about coastal wetland restoration of one of the last remaining Baymouth Bar coastal wetlands on the western end of Lake Ontario and the creation of new coastal wetlands in the Credit River watershed. Our last two presentations will extend our focus on barrier-protected coastal wetland systems, with Pete Zuzik speaking about the importance of protecting littoral cell geodiversity and restoring barrier landforms, and Joshua Nguyer, who will be sharing with us the example of restoring wetlands and coastal resiliency at Braddock Bay in New York State. We'll be taking a few questions after each of the presentations as time allows, and we'll also have a collective panel discussion at the end. So please input your questions in the Q&A throughout the presentations, and where possible, please direct your questions to specific speakers. I will now invite Greg to share his screen while I provide a brief introduction to Greg. Greg Main is the Habitat and Species Unit Head with Environment and Climate Change Canada's Great Lakes Ecosystem Management section. Greg began his career as a biologist with the province and later as a wildlife toxicologist with the Canadian Wildlife Service. Since 2004, Greg has co-developed various Great Lakes plans, including lake-wide action and management plans, biodiversity conservation management strategies, baseline coastal habitat surveys, initiatives for community-based action, and most recently on coastal wetland vulnerability, resilience, and adaptation. And Greg, I see that your presentation is now up and in presentation mode, so I'll pass the floor now to you.
Okay, thanks very much. So good afternoon and welcome to returning participants and to newcomers joining our third webinar session of the week. This introductory presentation reviews what we learned over the last couple of days, provides some thoughts on resilience, and introduces adaptation strategies to enhance wetland resilience. We've enlisted the help of several speakers, as Sharon pointed out, to bring some of these strategies to life through their work and experience. But first, let's review why resilience and adaptation are imperatives. Ensuring that our remaining wetlands are climate resilient is vital because of the many benefits that they provide to the Great Lakes freshwater ecosystem and to the Great Lakes population. And I provide a caption on this slide just to give you a snapshot of those ecosystem services that we value so much. We've lost a huge proportion of coastal wetlands since pre-settlement times, and the remaining coastal wetlands continue to be threatened by development, agriculture, and other land uses. We have learned that the climate of the past will likely not be the climate of the future, and that climate change is a critical threat to coastal wetlands and to Great Lakes biodiversity. Lastly, regardless of any mitigation measures, resilience and adaptation should be cornerstones of conservation moving ahead. Easier said than done, right? For the most part, resilience and adaptation remain theoretical concepts that are poorly understood and untested. Conflicting land use values and interests, multiple jurisdictions at play, and the politics and trade-offs make adaptation challenging. And moving from incremental to even transformative adaptation is most challenging, although we are beginning to see positive signs and examples, not only in the Great Lakes, but along our coastlines in the maritime regions. Recall that in the context of our study, resilience refers to a trait or capacity of a wetland to cope with climate change. Adaptation, on the other hand, refers to the deliberate actions taken to adjust to climate change, to avoid harm, and to enhance wetland resilience in our case. There's a growing body of information and several frameworks like this one, all with a few things in common, such as adaptation should be an iterative process. As you now know, it begins with an assessment of vulnerability. It involves identifying adaptation options, which will be the focus of today, tomorrow, and Friday. It entails the design and implementation of projects, evaluating project outcomes, and continuous learning and improvement. The most important aspect of adaptation are people, communities, partnerships, and institutions getting work underway and learning together. Let's quickly revisit what we learned from our vulnerability study, starting with climate and lake level projections. This is the first step in understanding what is it that we should be resilient to, or the resilience to what. Recall that Frank Saglenix of the Meteorological Service of Canada shared new climate and lake level projections. We heard that annual and seasonal air temperatures are projected to increase across the basin compared to the baseline period outlined in the dashed marks. The greatest increases are expected for Lake Superior, but increases are likely for other lakes, such as Lake Erie, shown on this slide. Annual precipitation will also likely increase by the end of the century and in all seasons, although the increase is generally less in the summer. The darker colors are for the worst case emission scenario, or representative concentration pathway 8.5. That's a business as usual case scenario. And the lighter color is the projection used using the intermediate greenhouse gas emission scenario, RCP 4.5. Ice cover, while not part of this study, is variable but generally declining since the 1970s. This trend is expected to continue across all lakes, especially under the high emission scenario. Average ice cover over Lake Superior and Erie show the greatest projected declines relative to other lakes. Of great importance to coastal wetland managers is that lake levels are projected to increase in variability, with even more extreme highs and extreme lows possible under the higher emission scenario shown in the darker shading on this slide. With the warmer winters, decrease in ice cover, severe storm events, coupled with greater wave energy and lake level extremes, we should brace ourselves for future challenges, such as possibly more flooding, shoreline erosion, pollutant runoff, and even more shoreline hardening that can alter sediment transport, damage barrier protected wetlands and diked wetlands, and impact native species, some of which are at risk. Over the last couple of days, you heard that 4 branches within Environment and Climate Change Canada undertook a vulnerability assessment to better understand the risks and possible impacts to coastal wetlands. This is the first of its kind study that integrates wind, wave, lake level projections into a coastal wetland response model with modeled outputs used in the wetland sensitivity analysis to determine potential impact. And this, in culmination with a spatial analysis of adaptive capacity, provided us with a lot of information that can be applied to adaptation and general wetland conservation across the basin. Each of these components of vulnerability were presented in great detail on Monday and Tuesday, and also recorded just in case you missed it. Briefly now, the wetland response model provided outputs including digital elevation models for each of the 20 coastal wetland sites monitored. Actually, there were more, and we actually have information for upwards to 26 wetlands. And visualizations on simulated changes to 4 to 5 different wetland vegetation community classes over time, that is to the end of the century. For example, this slide shows that changes in Rondeau Bay under the upper bound lake level scenario shows a greater loss in submergent aquatic vegetation than a gain, and a gain in marsh habitat at the expense of swamp. The model also provided insight into possible wetland area gains and losses. In general, losses were found to be to a greater extent under the upper bound lake level scenario than the lower bound lake level scenario, as shown by the orange data points on this slide. The wetland sensitivity analysis found that all wetland study sites are sensitive to climate-induced lake level changes, but to various degrees. On this graph, you can see that some wetland sites had an overall lower sensitivity or risk in the green shaded area. But for the most part, the majority of the wetlands studied are at risk, shown in the yellow shaded area. Yet several wetlands were ranked as at critical risk, with points extending into the red shaded area on this graph. This slide shows that wetland sites with the lowest adaptive capacity were located in the Lake St. Clair, Detroit River, Western Lake Erie, and Western Lake Ontario areas. And Morgan provided an explanation in her talk yesterday wherein she explained several indicators, including landscape condition, wetland biological condition, the potential for wetlands to migrate or transition under lake level change, and level of protection. And finally, this map shows the integration of information and the overall vulnerability categories for each wetland study site under the intermediate emission scenario. and specifically the results of the lower bound scenario with future lower or stable water levels shown on the left-hand side of each circle, and the upper bound scenario with higher water levels shown on the right-hand side of the circle. Vulnerability ranges from very low to very high, and this is illustrated by the green, yellow, orange, red, and crimson colors, with green being the lowest and dark crimson being the highest in vulnerability. In general, we found that wetland vulnerability differs across the Great Lakes. Wetlands are vulnerable to projected climate change, and especially under the upper bound scenario with projections for higher lake levels. We also see a cluster of highly vulnerable wetlands in Western Lake Erie, the Detroit River, Eastern Lake St. Clair, and to a lesser extent, Western Lake Ontario. But note that, again, all wetlands are vulnerable to projected climate change. Now, with that refresher, I'd like to transition to a brief introduction to a recent paper produced as part of this study called Adapting to Climate Change, Solutions for Coastal Wetland Resilience. It's really important to note that this work is framed as an entry point for adaptation and should be viewed as the beginning of a much longer conversation. It's intended for natural resource management agencies, conservation organizations, policymakers, planners, environmental non-governmental organizations, indigenous communities, industries, and landowners, all with stake in coastal wetland conservation. So developing a suite of adaptation strategies involves several authors shown on the slide, a comprehensive literature review and synthesis, insight from a multi-agency or multi-organization advisory committee, and also your input through workshops, interviews, and reviews of the white paper. The paper is largely based on accepted principles and preconditions found in published papers and books. Not surprisingly, some of these were already identified by you during our discussions. The points, while familiar, help us move from theory to practice by considering the ecological and geological setting, as well as the social, cultural, political, and economic dynamics at each of the project sites. Working at an appropriate scale and identifying and protecting key patterns and processes that operate within a wetland, within a catchment, and the shoreline and nearshore reach. Ensuring connectivity of wetlands to the lakes, rivers, and pools, and with adjacent upland terrestrial habitat. Maintaining and improving structural complexity, diversity, and functional redundancy. The latter speaks to the multiple similar and overlapping patches, plant species, and communities that serve as the insurance effect of biodiversity. This in the event that some plant species are lost and others can perform similar functions. As mentioned, adaptation is about proper governance, as well and well-connected people, institutions, and partnerships across jurisdictions. Above all, we have to avoid negative impacts and consider the use of an adaptive management approach or framework. We found that adaptation is complex and there's no one size that fits all solution. So we learned from other approaches and developed a framework that consists of a continuum of options ranging from overarching resilience pathways such as resistance, resilience, and transformation to high-level adaptation strategies to more detailed and nested adaptive measures and possible options with examples gleaned from the literature. While resistance to and recovery from climate impacts are fairly straightforward, transformation is much more complex, possibly contentious and poorly defined in practice for the Great Lakes. The concept is, however, gaining traction elsewhere and consists of several characteristics shown on this slide. It's said that transformation reduces the root causes of vulnerability by shifting social and ecological systems away from undesirable outcomes. Transformation is at a scale and ambition greater than incremental approaches, highly collaborative, and embraces fundamental changes to the way we value and manage natural assets like coastal wetlands. Just an example, building a lakefront wall to protect the shoreline from erosion exemplifies an incremental adaptation. However, changing land use and development practices and shoreline regulations, especially at vulnerable shoreline areas, are examples of transformational adaptation. This slide once again acknowledges your participation on many aspects of this study, including developing these adaptation strategies and measures that you'll learn about over the next 3 days. We set out to ensure that many of you were engaged as possible and that your interests and needs were considered. There are many adaptation approaches. However, we landed on 6 overarching strategies with over a dozen nested features or nested measures and a selection of potential options that range well into 150. I'll now turn it over to Anders Holders, who works with me, to introduce our first 2 strategies before we ask our invited speakers to share their knowledge and experience.
Great, thanks, Greg. Good afternoon, everyone. Today I'll be introducing adaptation strategies 1 and 2, which will be found in the report, Adapting to Climate Change, Solutions to Enhance Great Lakes Coastal Wetland Resilience. In the interest of time, I will just be briefly touching upon both strategies and select measures that will complement our presenters. You were clear from the onset of this project that one of the best ways to increase coastal wetland resilience is by reducing the impacts of existing non-climatic stressors and improving the natural capacity of wetlands to cope with climate change. Strategy 1 focuses on reducing non-climatic stressors and enhancing wetland adaptive capacity. The key adaptive measures associated with Strategy 1 are maintain and enhance wetland water quality, reestablish hydrologic connectivity, restore and conserve landscape connectivity, and prevent, detect, and control invasive animals. So why is this strategy important? As of 2018, agriculture accounted for 53% of the land in Southern Ontario, the majority of which is tile drained, which accelerates phosphorus and nitrogen losses from soils. Sediment loading, nutrient enrichment, and chemicals from agricultural and urban runoff degrades coastal wetland water quality, which negatively affects wetland plant community, wildlife, and overall biodiversity. This decrease in diversity and number of species reduces the ability of a wetland to respond to change and deliver ecosystem services. To better understand habitat quality in the Great Lakes coastal wetlands, Harrison et al. Found that water quality from 511 US and Canadian wetland sites was correlated with land use and land cover. The results show that water quality in Canadian coastal wetlands is poorest in Western Lakes Ontario and Erie and Southeastern Lake Huron. In contrast, the wetlands in Georgian Bay, the North Channel, Manitoulin Island, and Lake Superior have high water quality and natural land cover. First measure presents options for enhancing water quality in urban and agricultural settings, a focus for today's webinar. These adaptation options for urban and agricultural lands are intended to prevent and reduce nutrient and sediment loadings at their sources through sustainable land use planning, alternative farming practices, and green infrastructure. Implementation requires collaboration across boundaries and stewardship by local organizations to garner the support of public and private landowners. Examples of adaptation options include creating upland and riparian vegetated buffer strips to stabilize eroding stream bank and reduce runoff, incorporating 2-stage drainage systems in low-lying areas that mimic natural floodplains, installing and maintaining green infrastructure to promote stormwater retention and infiltration in urban areas, and improving existing stormwater infrastructure and best management practices. Under the combined effects of climate change and anthropogenic activities, there can be negative changes in the hydrologic connectivity pattern within aquatic systems. Rivers, streams, lakes, ponds, springs, floodplains, and wetlands provide important linkages between Great Lakes aquatic and terrestrial ecosystems. Unimpeded longitudinal and lateral connectivity between these ecosystems facilitate the exchange of sediment, nutrients, plants, animals, and energy, which creates the conditions necessary for the development of refugia. This measure provides options to reestablish hydrologic connectivity and the conservation of wetland ecosystem services. An example issue would be when the connection between a coastal wetland and the lake has been compromised. An adaptation option would be the modification or removal of man-made barriers such as bridges and or causeways. A recent example of where this option was put into play was the improvement of the Long Point Causeway by the Long Point World Biosphere Reserve Foundation. Constructed in the 1920s to ease access to the Long Point Peninsula from the mainland, Since the 1950s, high Lake Erie water levels and associated storm surges have flooded out the causeway, restricting access to residents, visitors, and increasing road mortality of local wildlife. The project comprised of reestablishing the hydrologic connectivity using box culverts to facilitate nutrient exchange and manage the expansion of Phragmites in Big Creek National Wildlife Area. The project concluded in 2016, and the results have been positive for humans and animals alike. Agriculture, urban, rural, and shoreline development are the main causes of habitat fragmentation over a large proportion of the Southern Ontario landscape. Landscape fragmentation threatens biodiversity and impedes native species and habitat adaptation to climate change. This map shows the results of landscape connectivity assessment from the Canadian Great Lakes Baseline Coastal Habitat Survey. Lake Huron, Georgian Bay, and the Bruce Peninsula varies between good to very good connectivity, but fragmentation increases moving south from Kincardine towards Sarnia. Lake Erie is experiencing high fragmentation, with exceptions being in the St. Clair River, the Wapple Island Delta, Eastern Lake St. Clair, and the protected parks such as Point Pelee, Rondo, and Long Point. Much of the landscape at the western end of Lake Ontario is also highly fragmented. However, the eastern coastal system is largely intact. And while extensive efforts have been made to address landscape connectivity, climate change is exacerbating these impacts. As the climate warms, there's a need for climate-smart options to increase landscape connectivity. Restoring lost connectivity between coastal wetlands, uplands, streams, pools, and ponds is key to wetland biodiversity conservation and the resilience of habitats and species to climate impacts. This measure addresses the need to restore and conserve habitat connectivity within and between wetlands, other aquatic habitat, and the broader coastal terrestrial landscape. Some examples of adaptation options include ensuring areas being restored or created contain diverse topography, temperature gradients, wetland types, and connections with adjacent habitats with different microclimates. Also identifying and prioritizing the creation and protection of natural corridors between coastal wetland ecosystems and adjacent aquatic upland habitat. And finally, reconnecting rivers to floodplains by removing barriers or to implement designed ecological flows to mimic those natural flow events. Some presentations this afternoon will be speaking in detail on the littoral cell geodiversity and barrier landforms, so I will only introduce this strategy. Many barrier protected wetlands and the native species they support are sheltered from the energy of the Great Lakes by sand and gravel spits, bars, and beaches. The measures associated with Strategy 2 provide options to protect the geological diversity and the natural processes that operate within littoral cells. The key adaptive measures are update land use policies and regulations, employing integrated coastal zone management principles to develop littoral cell management plans, reestablishing sediment supply and alongshore sediment transport, and implementing local projects to protect and restore these barrier landforms. So why is this strategy important? Littoral sediment supply is essential for the creation and long-term maintenance of sandspit features that shelter large wetland complexes. On a large scale, shoreline hardening disrupts natural sediment transport and beach nourishment, increases erosion at the adjacent shoreline reaches, degrades wetland habitat, and restricts wetlands from migrating laterally into the upland habitat. Some examples of shoreline hardening and reduced sediment supply impacts include the barrier beach at the northeast corner of Point Pelee National Park, which has retreated more than 300 meters inland, resulting in a loss of over 80 hectares of coastal wetlands. The Rondo Bay Barrier Beach, which has eroded inland 650 meters over the last 150 years, has resulted in the loss of more than 240 hectares of coastal wetlands. And recently in 2020, the barrier beaches of Hillman Marsh and Big Creek Marsh were both breached. The implementation of this strategy's measures and associated options will allow for transformational, multi-jurisdictional, and multidisciplinary approaches across littoral cell boundaries that can restore sediment dynamics, enhance and restore barrier protected wetlands and other coastal habitat, reduce coastal hazards, and increase resilience. Thank you, and I will now pass it back to Sharon.
Thanks, Greg and Anders, for the great overview and for setting the stage so nicely for our 5 guest speakers today. Next, we will be hearing from our first guest speaker, Laura Ellis. Laura, please go ahead and share your screen while I provide a brief introduction. Laura Ellis is a Senior Vice President of Policy and Partnerships of ALICE Canada. She is eager to scale the conservation work of ALICE Canada by finding effective ways to strengthen environmental protection and grow community sustainability and resilience. Laura is focused on the development of new regulated and unregulated ecosystem services markets and growing support for natural infrastructure on agricultural lands. Laura, I see that you're all good to go. The floor is yours.
Thank you. Thanks very much for the invitation to be here today. I also wanted to just mention that ALICE has a new program in partnership with Toronto Region Conservation Authority and Credit Valley Conservation Authority in Peel Region. And also to mention that some of the examples of wetland projects that we're going to see today were funded by the Great Lakes Protection Initiative a few years ago. So I stole this slide from one of my colleagues because I thought it was a little bit cute. Hopefully some of you know ALICE Canada. ALICE originally stood for Alternative Land Use Services. And if any of you are associated with any of our programs, maybe you could put that into the chat box, since we work with many people across Ontario and the country. We are always trying to expand that. And I always like to give people the opportunity to talk about their own experience with the organization and what we're doing across rural landscapes across Canada. So ALICE is about putting nature back on agricultural lands. Our vision is to sustain agriculture, wildlife, and natural spaces for communities and future generations. And our mission is to help farmers and ranchers build nature-based solutions on their land to sustain both agriculture and biodiversity for the benefit of communities and future generations. So ALICE was conceived in 2008 in Manitoba by a number of farmers. Our organization continues to be led by farmers. We have partnership advisory committees that make decisions for each of our community programs. Each of those is chaired by a farmer or a rancher. And the committee is made up of at least 50% farmers. And of course, farmers are the people within our system who are actually implementing nature-based solutions. So this slide was obviously put together by somebody on our Alberta team, since it talks about the number of communities in Alberta. It's now also out of date, so we're growing super quickly. We have 32 community programs across the country. In Ontario, where we added a new pilot in Peel Region, as I mentioned, with partners TRCA and CVC. And we're also opening a new program in Lanark in Eastern Ontario. But you'll notice we are very much clustered in southwestern Ontario, where we have a lot of great programs, including our largest program in Norfolk County. So ALICE is focused on the production of biodiversity and ecosystem services. We are geared towards restoration and producing more of all of these things that benefit the environment and our communities. We often think about problems that we're addressing. We like to consider ALICE a solution provider. So, and this very much relates to how we seek investment for our program. But there's always the problems, and then we try to think about the solutions and how we can do more and more of that. The only thing that's the real critical barrier for us in terms of expanding and doing more and more is always resources. So trying to figure out how to resource and how to get more partners and more support for our program is always top of mind. So what do we actually do? So a lot of the solutions that were spoken about in the previous presentations are things that are our bread and butter at ALICE. So we are working on rural landscapes, putting nature back or enhancing existing natural features. We really, a lot of our projects are in marginal farmland. So areas that are too wet, not great, too steep, not great for farming. So why not put those back into nature and reap all of the rewards that that provides? So you've got a whole list here: bank restoration, wetlands, planting trees, keeping livestock out of water bodies. We do an awful lot of those projects. We have just received a new contribution from Ontario Ministry of Environment, Conservation and Parks to expand the number of wetlands that we'll be able to do across Ontario, which we're very excited about. And as I mentioned, we did have some funding from Great Lakes Protection Initiative to do some wetlands in Ontario, which was really great, and other water related projects. So of course, there are many biodiversity benefits of ALICE and all the different sorts of projects that we do. And okay, so now I realize I forgot to turn my clock on, Sharon. So maybe you want to, if I'm going too long, which I have a tendency to do, if you could put something in the chat box for me. I'm just going to do a brief overview of some of the projects, about how the whole mechanism of our projects, which of course are important for building resilience, you know, flood mitigation, drought mitigation. We found during this last really dry season out west and in Ontario that farmers that had more natural infrastructure did better than producers that didn't. So there's, you know, it's complicated how all of these things interact, but I'm just going to run you into sort of how our project, how we get these projects on the ground. So first off, it's important to note that ALICE is completely voluntary. So farmers and ranchers generally find out about our program from happy participants. So we know from a survey that was funded by GLPI that most of our participants, are people who are putting nature back on farmland, do not work with any other conservation organizations. Some do, and we've got some great examples where you might see a wetland, you know, put in by Ducks Unlimited, and then an enhancement around it that's supported by ALICE. So we do like to work with our conservation partners, but some of our participants are only working with ALICE on this sort of thing, and maybe that's a gateway for other organizations too, of course. So the first thing is that we meet with future potential participants, one of our coordinators will, and talk about what the farmer or rancher would like to do, what would make sense, and really good to get a good feel of their interest and what's possible on their land. So next will be a pretty robust plan development and budget planning. So we take funds from all sorts of different funders, philanthropic, corporate, government, and do a lot of matching. So some of our projects are quite costly, of course, and so making sure that there's money for startup costs, ongoing management and maintenance. Landowners contribute as well, so that's all a pretty intense process that has to take place for each project. So our coordinators are very tuned in to what's going on with each of the projects. We also work with groups like Ducks Unlimited on the technical specs for different projects. So we make sure that we are tapping into expertise for all of the design and implementation of our different projects. And so at the end of the day, we will have our projects in the ground, some of them filling up with water. We map them and we account for the area for our funders. We also, payments are based on generally on the area of land that the projects take up. So we are very careful to make sure that all of this is properly mapped, and we have verification processes as well to make sure that verification and monitoring to make sure that projects are being maintained and are continuing to exist and aren't taken out by the landowner. So this is a great slide. I'm not going to read that. Maybe you guys can scan that if you can read that small. But you know, a lot of thought goes into the design of our projects, what species are used, integrating that with other natural features for landscape connectivity. A lot of our farmers will come and want to do one sort of project, and then they'll come back the next year and want to do another project. So we often think about, you know, how do we build, you know, complexes of projects, and what will that look like in the future. So a lot of thought goes into each one of these projects. We have an absolutely incredible operational team with coordinators in each region. We have farmer liaisons who will go and talk to other farmers about the program and the sorts of projects they can do. So I'm always impressed and like to spend as much time with our operational team as possible. So here's a wetland project. I think this is one of the ones that was funded by GLPI. And so that's another picture of that. Here's one in Thames River. There's a floodplain and a wetland. Anyway, everyone loves the before and after picture, so we try to do as many as possible. But you know, these are just sort of, you know, projects that we would, you know, sort of standard sorts of projects that we would do. So here's, of course, in the Great Lakes region, we are particularly, especially Lake Erie and all of our programs down in the basin, we are particularly concerned with trying to keep nutrients out of water, out of the lake. And so we have a lot of pretty sophisticated connected wetlands that are really great. And we do a lot of tours. So if people are interested, they can get onto our mailing list and go and see some of these projects and meet the people that put them together and the farmers that are maintaining them, which is always just a great experience. So we also do wetland enhancements and wetland buffers. These are important, of course, to keep nutrients out of riparian areas and wetlands. And add a lot of ecological function. So this is something that is sometimes of great interest to our participants. It has a great value. So here's some more buffers going in. We try to use native species as much as possible. We now have funding from the 2 Billion Tree Program, which is great. Here's an example of a drainage ditch that I was once accused of not the before and after not actually being the same project. So I do point out now this took 8 years to get from the before to the beautiful, glorious after shot. So, and you can imagine if any of you know about restoration projects, just how much work it takes, right? So the site prep and then the planting and all of the things that you have to do to make that much progress in an area. So in southwestern Ontario in the Lake Erie Basin, we also do an awful lot of native tallgrass prairie restoration. So of course, important for biodiversity and also water retention and landscape connectivity. So some of this is supported by Species at Risk funding from Ontario government and other sponsors. So some of you might be asking, this is great, but why do farmers want to do this? How do farmers benefit? So in terms of payment, producers get cost share from us. Annual payments are made. It's really important to understand that those annual payments are tied to management and maintenance. It's not money for nothing. They don't put the project in and walk away and leave it. So those payments are tied very much to the amount of work that it will take to increase the productivity of the project and make sure that things like invasive species don't detract from that. And of course, they get the expertise from the local committee, which is called a PAC, or Partnership Advisory Committee, and also from our coordinator and other people associated with the program. When we did do our survey funded by GLPI of farmers in Ontario, we were really surprised because they all complained that they weren't getting enough of our time. So they wanted to see the coordinator more, they wanted to have more interaction. So that sort of is something that we don't explicitly fundraise for. So interesting to note that that landowners are interested in getting more information and more help and being more plugged into those things. So Alice is a principal, you know, we're guided by principles. So as I mentioned, it's voluntary, it's integrated. So we work with as many different NGOs, conservation authorities, governments, researchers, as we can. That makes our program stronger and better. We also don't want to duplicate efforts. So we do co-fund projects with other NGOs. We're now receiving money for projects from World Wildlife Fund. We work closely with Ducks Unlimited in Ontario. So we want to make sure that we're maximizing what actually happens. And here's a picture of one of our partnership advisory committees. So each community, as I mentioned, has one of these committees. They make decisions about which projects are funded. The committee is at least half farmers and ranchers. We also will have municipal representatives, reps from other NGOs. And so it's really important that they get the best information that they can, and they are very good at making decisions, which is evident at how successful the program has been. So I don't. So anyway, we have guidelines, and there are, you know, certain things that how we support those partnership advisory committees is sort of become more sophisticated over time. So this is just a little bit about our process. It's you know, third-party verification, as I mentioned, is important because we have to give our investors some security in their investment and that we're producing what we said we would. This is a little bit too about the process. So yes, farmers express interest, sign on to the program. The projects are designed with the farmers. And as you can see here, this is sort of a complex of different projects, creating some connectivity. And we do have scoping to make sure that we are actually, that our partnership advisory committees, we are adding ecosystem services. Our projects are geared towards restoration, enhancement of other natural features, and meeting local priorities as well. So yes, our payments, we cost share around establishment, and then there are annual payments for management and maintenance. And a really important part of our program, of course, is having sort of recognizing what our participants have done, how it's contributing to local and regional environmental priorities, but also through our demonstration farms, actually bringing new participants into the system. So we have signs on our project. Some of our communities have put up this is a billboard in Middlesex, which is just great. We have some up in some of our Quebec programs as well. So we like to recognize the great things that our participants are doing and also get other landowners on board. As I mentioned, we do tours. I would highly recommend tours. We do you know, evening tours on weekends to the demonstration farms. And it's always a really great time. So if people are interested, I would you know, hope that you can get out and meet some of our people. As I mentioned, we do try to work very closely with our conservation partners. I mentioned Ducks Unlimited before, Forests Ontario, conservation authorities. These are all super important. We have a list on our website of all of our partners, and it just grows every year. So it's very important to our success. We're involved in testing new technologies. We're working with University of Guelph and Dr. Wan Hong Yang on IMWeb's hydrological modeling to evaluate the contributions of our projects to water quality and quantity. Some of that work was supported by Great Lakes Protection Initiative, and now we're working with RBC Tech for Nature on that. But this is all important because we know we need to be able to quantify outcomes. We need to be able to target. So that's all really important to our growth and being strategic. So these numbers are a little bit outdated. I think they're from last year, but those 32,000 acres are totally restored land. So land that's been taken out of production and put back to nature. So that's quite a lot of land in very affected parts of Canada by development. So I'm going to wrap it up there. I hope I didn't go over, Sharon, but looking forward to the other presentations. Thanks.
Thanks, Laura, for a great presentation. You're right on time, so no worries. And I'm sure there's a lot of questions from the audience, so please continue to input your questions in the Q&A box. We'll take a few before we hand it off to Ralph for the next presentation. So Laura, you've shared some wonderful examples before and after project's creation. Stephen is wondering if your group monitors the effectiveness of restored wetlands in filtering nutrients. How often are projects monitored after they are completed? And is this monitoring done by Alice Canada?
So we've been working with University of Guelph in a few different ways. So Dr. Andrew McDougall's lab has been doing some work in that area on some of our projects. We also are working on the modeling with Dr. Wan Hong Yang. So because our objective is always to put money into the ground. That is our focus. And so we work when possible to work with researchers and groups that have the budget to do that sort of work. So I can reach out to our network and find out more specific what some of those examples are, but we do it as much as possible. And when we have information about if specific project attributes make our projects more effective, then that information goes through the network so that can be factored into design of future projects. So I hope that's clear, but it's, our when we raise money, so even when we get money for research, we always try to match it for dollars on the ground. So we're a little bit opportunistic, I guess, in terms of the monitoring and research partnerships that we can generate.
That's great. That's very helpful, Lara. And what methods do you use to quantify ecosystem services, and how do these translate into annual payments? If you care to elaborate a little more.
So our payment rates are generally based on land rental rates for marginal land. So as we get more sophisticated, we might be able to say, well, you're filtering this much phosphorus, or your projects are having this outcome, so we could tie payments to that. But right now, it's basically tied to land rental rates, and the management and maintenance payments are pretty much geared towards what the farmer has to do for the project. So in southwestern Ontario, we do lots of Phragmites control. If we've got exclusion fencing, how much of a farmer's time and materials will it take to make sure that the fencing is up, is still good, that repairs are made. So the payments are really geared towards time, I think, rather than an outcome.
Thanks, Lara. And last question before we go to Ralph is, based on your map of Alice communities at the beginning of your presentation, it looked like most of the communities in Ontario were located south of Lake Huron or north of Lake Erie. Is that correct? And are there specific considerations in the different lake basins that you work in?
So we've expanded in Ontario, so we have quite a large area in eastern, southeastern Ontario, which we call Ontario East. It's two different conservation authorities, our partners there. We also just started a program in Lanark County. I don't think it's been publicly announced yet, but that will be happening very soon. And of course, with our partners, TRCA and CBC, we've got a new pilot program in Peel region. We also have a program in Grey Bruce counties, so up Owen Sound, up Markdale area, and a little bit further east. And then, yeah, the rest are down sort of in southwestern Ontario. And so the reasons for that are, you know, we obviously are working with farmers and ranchers, so areas with a lot of agricultural production are where we are located. And it's also because of the program being so grassroots, communities will see their neighboring community have the program and hear farmers and other people talking about how successful it is. And so then the neighbor will want the program as well. So it's sort of a little bit like a mushroom, you know, mushroom growth as different communities find out about the program. I think there was another question in there. Sharon, I don't know if I covered everything.
No, that was great. Unfortunately, that is all the time we have for the question right now, but we will save all remaining questions to the panel discussion at the end, and we'll re-invite Laura to join us for the panel at the end of the day. So please do keep your questions flowing, and thank you again, Laura, for the excellent presentation. I will now invite our next speaker, Ralph, to join us. Ralph is Associate Director of Restoration Resource Management at Toronto Region Conservation Authority. So Ralph currently oversees a large team of restoration resource management professionals that restore over 120 hectares of habitat annually. Projects include wetland and aquatic restoration, integrated shoreline management, terrestrial natural cover enhancement, and essential habitat. And Ralph, of course, has been restoring wetlands for over 25 years. I see, Ralph, that your slides are up and in presentation mode, so I'll pass the floor now to you.
Great. Well, thank you very much. This has been excellent so far to hear the earlier talks. I appreciate being contacted regarding this. I think I'm going to try to really tool this into the session sort of question of coastal wetland resiliency and techniques that we've been using to improve the adaptive capacity. Some of my talk really fits well in tomorrow's session as well around water levels and controlled wetlands. So I will take you through a bit of a story of what we've learned, lots of lessons learned. Truthfully, we said 30 years, so I'm cheating a little bit and borrowing some of the work that was done from our predecessors. Of course, this is a team approach. I'm super privileged to work with an amazing team of restoration professionals. And truthfully, luckily, or we're sort of blessed with having a large team and opportunities to do some pretty amazing work. The work that I'll present here really fits well because our basic goal of restoration is to protect and restore ecosystem function and health for the benefit of ecosystems, services, and resiliency. Our goal, everything that we are doing actually is looking at restoring resiliency. So I think a lot of what we do is very applicable here. We are Toronto, however, we do oversee 194 kilometers of Lake Ontario shoreline. It's a 72-kilometer stretch directly sort of between Mississauga and Ajax. And first and foremost, a lot of the shoreline has been dramatically altered. The 1780 sort of photos here of Toronto waterfront being a giant Ashbridges Bay marsh, which is now the Portlands and the waterfront. And a lot of what we're doing is some may say it's creation. It's restoring what was once here, but is truthfully, in some cases, we're building brand new habitats. But using the unique criteria of the mouth of the Don River to really be the anchor for why we're doing what we're doing. We do also have some very significant coastal marshes in the Duffins Marsh and the Rouge Marshes, the Humber, really about 10 sort of major coastal marsh systems. But then, as I mentioned, sort of 194 kilometers, not including the shoreline in the Toronto Islands that can also be classified as coastal wetland. As I mentioned, we are sort of blessed here. Sort of since 1995, we've restored about 200 or just over 250 hectares of wetlands. Specifically, if we look at the coastal wetland component of that, roughly about 65 hectares of either new or restored wetlands. And we really developed this program, and it has been a large focus, especially as a result of a lot of waterfront development that has taken place. So taking us through a bit of the story, wetlands in our early work, especially in the early 90s and into the mid to late 90s, was very species and, well, not only us, but it was the beginning of the RAP, lots of things about black terns, pike spawning habitat. A lot of our work was really to bring complexity back into some of these shorelines. Pike spawning was one of the typical ones that I think we in the early days have always been very spawning focused, because a lot of the waterfront development work and just the urban influences had really reduced the natural habitat within the nearshore area. We built cottages, shoreline development, right to the water's edge, and we've lost that natural progression of shoreline to go back and forth, particularly something like a pike being sort of a high trophic species and a bit of a trophy species to really plan around. Needing these, shallow water emergent areas, dead vegetation, these fluctuating areas, we were really sort of pike spawning habitat focused and developing pike spawning channels, which we've proven, produce a ton of pike. But as we see later in the talk, not always would they survive to adulthood. In this time period, again, we really looked and scoured the landscapes to look for these essential, sometimes called critical, but I know, of course, with species at risk legislation, those words become confusing, but these are essential habitat features, whether they be woody material, nesting platforms, isolated amphibian pockets, snake hibernaculums, of course, with fluctuating water levels, floating tern rafts or tern islands, and not just within the sort of the terrestrial or the shoreline, but also substructure wise. Fast spawning shoals are definitely things that we were doing a lot of. Woody structure, log cribs, attached reefs, cluster nodal nodes of planting. Really, a lot of the focus around this time was very focused on this specific, generally spawning and breeding requirements that were generally wiped out because of urban development. And it was really focused on putting some of these back in place. I think for some of the people here today, I'm sure you may have seen back in 2003, we really sort of brought all these ideas together, developed the Toronto Waterfront Aquatic Habitat Restoration Strategy. And really it was meant as a cookbook of techniques, opportunities, but really in layering in the biological processes so that we could understand how these work within a lake environment, because coastal wetlands are not just single units unto themselves. So you'll see a lot of these images came out of this structure. This is where we really, started moving away a little bit from the species, because we were finding that these species were using this. Bass were spawning on the spawning shoals. The pike were using the channels, but we were still sort of missing some of the building blocks of the environments. And really the focus really started to go to emergent vegetation. Why aren't we seeing the emergent vegetation that historically was here? We saw a lot of wetlands that had, good structure, but we were missing those large bands of emergence. And we really started looking at water depths and lake levels, understanding that Lake Ontario is a very dynamic and has changed dramatically from historic times. And then we pinch those wetlands into the urban development. So, you know, looking at, in the cases of wetlands where we have the opportunity to put them back in place, like some of the work we'll talk about at Tommy Thompson Park, or the mouth of the Don River, really putting some of these, you know, large bands of emergence or these isolated backwater lagoons and pools, woody structure. You know, we really started to think about these in the design of shorelines and implemented them quite successfully in many areas, but we still didn't sort of have it right. And I'd like to compare this image to, I know Greg presented, and we'll probably see it a few times throughout these strategies, the transition zones or the zones for various wetland communities. And it was interesting because we developed this really from a practical perspective and sometimes trial and error. You know, we would plant cattails that just didn't survive, and not always understanding the open water or the lake level processes that are really driving those communities. And through that work, tied in with also, you know, survey, good monitoring work, we really found that, you know, truthfully, when you look at our coastal wetlands in an annual year, the growth area does fall within a very tight band. And in actually a lot of cases, these bands are a little tighter than I think, you know, some of the modeling has shown. Great Lakes wide, or at least Lake Ontario wide. Within Toronto, and because of some of the pinned in areas, we see some very narrow bands of these communities, particularly the category of riparian shrubs and wet meadows. Really, a wet meadow is almost non-existent in a lot of our areas because you get that emergent fringe that grows right up to your edge. It is a wet meadow, but it also in our area becomes very dominated quickly by sandbar willow or some of the riparian willow species. And really, it's more, you know, a function of fluctuating lake levels and the disturbance regime, because those wet meadows will quickly turn to riparian, and the willow species will quickly dominate. This is all well, but really what we've seen in a lot of our shorelines is, and maybe this doesn't come up great, but under lack of vegetation, we see this simplification of our shorelines. We lose those gradual profiles, and you tend to get this little drop and a little lip right at the wave zone or right at that sort of 75 mark. And then you get a very uniform, you know, about, you know, 25 centimeter depth that really with high summer lake levels is too deep for emergence to grow. And this is typically what we've seen. So we really, a lot of our work is really trying to put this natural structure back in place to really enhance resiliency and robustness of natural shorelines, and particularly to support not only the establishment, but the continued development and proliferation of emergent vegetation. So vegetation was the focus, as I said, but then we all in the early 2000s really started to fixate on common carp here. And this is an image of a carp gate that we installed at Tommy Thompson Park at the Cell One project. Really, Ducks Unlimited and work by RBG and Coots Paradise had really done a lot of work looking at carp. And like all restorationists, we're always looking for that silver bullet. Went to lots of sessions. What are we going to do about carp? Carp are going to be, you know, pulled out of the lake because the reason wetlands are gone are carp. And carp do definitely have an impact. And in this case, that one almost made it over. We have a carp gate here that is restricting large body carp from the system. But as the video pans here, there's also the stop log structure piece, which will become very important as we talk a little later. And will sure come up as some themes tomorrow as well. But that stop log structure allows you to control water levels as well, given that we know lake levels are really a mess in Lake Ontario. So in this situation, you know, there was lots of projects to really install carp gates. And this is what's called, and I think people have probably seen some of these pictures before. This is Corner Marsh, and this is part of Duffins Marsh. And a carp exclusion, I won't say gate, but it was a full barrier essentially put in place here. This was a project that we did in partnership with the Ducks Unlimited, the town or city of Ajax. And it was an interesting story because the barrier, this was originally a connected lagoon like the other ones, and a barrier was put in. Year one, the barrier went in, 100% exclusion of carp. And you know, everybody assumed the vegetation would proliferate. Really, we saw some decent emergent from existing vegetation into the deeper water areas, but we didn't see large expanses. And what we didn't see is what we see in this photo here is clear water. Turbidity was still high, very similar to the other embayments. And this is an estuary area. The turbidity is a common piece, but the turbidity just doesn't disappear. Then there was the ability to draw the system down, result in a huge proliferation of emergent vegetation, and then reintroduction of water. And then since that time, we've seen a very different system. Then we really saw not only the expansion of the emergent communities, but definitely a huge expansion of the submergent, floating leafed, you know, lilies and a variety of other things. And really, this is when we started to see the change take place. The dynamic between carp, water level, you know, again, it's a complex positive feedback system that it's difficult to control any one factor. Yes, carp are part of it. They, you know, bioturbate vegetation, they eat vegetation. By doing that, they create unstable sediments. They themselves, just by their action, create higher turbidity. Water levels, you know, going up and down in Lake Ontario, these high water levels that come typically in the spring and summer, create cold conditions in those lower areas, which further contributes to unconsolidated sediment. The end result is all of this just continues to cycle, and you need to really be able to control all of them. But if you only have the ability to control one, truthfully, we're finding that your projects aren't the success that they should be. I'll flash over this quick in time, but this is this interesting thing in Lake Ontario, and I love this graph. Every time I look at this, I'm like, you know, duh, like, no wonder we've lost our wetlands and our coastal marshes. You know, since water level control after the record low years where ships were grinding, you know, we installed Cornwall and have been regulating water levels since then. So we still see a ton of fluctuation, which we all know is good for marsh vegetation, but we don't see the lows. And it's the lows that's where emergence massively expands. And even in higher variability times with climate change, we're still going to see variability, but Cornwall is not going to let ships run aground. We're still going to have sort of an ultimate bottom to the low levels. Again, not to be a dissertation on plant growth, but this is just a stylized graph showing the dotted line shows what typical water levels would be in a lake or a marsh system, usually peaking in the spring after melts, early summer, and then as it draws down, water gets shallow and shallow. The blue line represents the ideal depth for growing emergence, and we see, like in a normal situation, you have a large blue and green band where the ideal growing season and the water depth perfectly match. Instead, because we manage water levels for shipping, which water peaks typically midsummer, we are only getting these ideal growth bands on the ends. Plants start to grow late in the season, but it's not late enough for them to root in to be successful the next year, or they grow in the beginning season and then they get choked out by water and don't survive. This is what we were seeing in a lot of our shorelines, and we really took that to heart. I know Greg and the team, we contributed as part of the Durham Coastal Monitoring, and everybody was definitely now moving on this theme of lake levels are one of the primary drivers of what was happening. So this brings us to the Cell 1 project. And the Cell 1 was probably one of the first projects where we really took the comprehensive approach of water levels, prime emergent depths, carp, turbidity, essential habitat features. And we had the opportunity to take what was basically originally a 9, almost 10 hectare CDF, or confined disposal facility. And instead of capping it terrestrially, turning it into a coastal marsh. So shortly after the work, this area was filled in. We truthfully installed every critical habitat feature we could think of. All got put in there: bass spawning shoals, turn mounds, woody material. And truthfully, it has performed better than we would have ever expected. We were a little focused, and if there is any critique, we probably we're thinking so specific on all these features that maybe packed a little bit too much in here. The one thing that we did miss was just large expanses of emergent vegetation. And we really were so focused on capping that we didn't really look at the soil type, and really, the quality of plants or the quality of the soil really needs to be thought about when you're putting vegetation back in place. We were really focusing on depth, but this was capped with very poor subsoil. And we did see, great establishment, but as this one picture shows over here, a lot of turbidity, and it's only been until recently, until we really finally are starting to see biological potential build up in the soil, that we are really seeing things taking off. I'm just going to skip over this one for the sake of time, because I do know I'm running a little late here. The next sort of project is this Durham, or is the Abatement D project, because this is the one thing that we did miss in that, is we really were focused on making warm water wetlands. This is one of the first projects where we really understand that the wetlands are also dependent on the lake around it. And one of the key criteria and the things that we are seeing with some of the monitoring going on is we're having fish overwintering in the wetlands, or when they're leaving the wetlands, where are they going, and are they coming back in the following year? We might be producing lots of fish, but they're not surviving the first winter. So in these situations, we've actually looked and been more focused on overwintering habitat, transition habitat in the islands and in the features and the shoals and things just outside the wetland, and thinking about lake seiches and cold water upwelling events and how the open lake controls the system. And this brings us to the Cell 2 project, which we will hope is the ultimate be all and end all, incorporating all these aspects: more overwintering habitat, all the essential features, the larger bands of emergence, and great connection and a lot of modeling around sessions and biological exchange. And just a couple of quick shots, as this was built out, again, bit of a dream project for our team to be working on. Took this basically 9 hectare coastal wetland, and this is an air photo image of it currently, and incorporating all those aspects. And we're really looking forward to continue to follow this through, as it's still in this early establishment phase. Just to finish off, we can't forget the invasive species. We've seen amazing things that have happened at these sites by finally getting in control of some of the Phragmites and helping with turbidity and habitat. And I will leave it there. This, of course, can't be done without a ton of partners that have really come together to help move this agenda forward.
Thank you so much for the great presentation, Ralph. We'll take a few quick questions before our break. So from your presentation, Ralph, it's clear that the approach to restoration has really evolved over time. Where would you like to see the restoration and adaptive management of coastal wetlands in the Toronto region go next?
I think that one of our key areas that we really want to focus on is the river mouths. These coastal wetlands, diked wetlands, or ones that are isolated off the lake, are in many ways easier to manage. The river mouths, the work that's going on at the Lower Don, continued work at Duffins, how the lake seiches and the lake processes impact the riverine system in that interface, how to get the things right in those areas.
That's great. Thanks, Ralph. And we had a question from Amanda. When you have the ability to alter water levels at a wetland project site, do you find that you need to continue to alter levels often throughout the year? If so, can you describe a typical management regime for us?
Yeah, definitely. I mean, our goal, and I probably didn't highlight it well, is that we really want the wetlands to function as wetlands. Coastal wetlands are the fish engines that run the nearshore community. So the goal is really using them more heavily in the establishment phase. And the hope is that you can let it run freely wide open for years on end, and implement the control when control is needed, when you really see senescing of the vegetation, or in some of these record water years, we did close some off and try to protect the investments from those uncontrolled high water levels.
That's great. Thanks, Ralph. And our next question is from a participant. Besides carp, have you looked at excluding other negative contributors, such as rusty crayfish, for example, to these created wetland areas?
Yeah, we definitely are part of a number of invasive species working groups. Ones like that, I mean, really, we address that through education. Carp are a very unique scenario to be able to control. So the other one's really through education and lots of signage and participating in lots of events and what have you is really the way to get the message out.
That's wonderful. And we'll take our last question from Christopher before the break. Have you had any wetland projects that are adjacent to shipping traffic?
Yes, definitely. And you'll see in that, if you haven't seen the Toronto waterfront naturalization or restoration strategy, there are a series of techniques for habitat improvements, and definitely vegetated shorelines adjacent to shipping, and boating is one of the real great things, like docks and marinas. We've done some great work at Toronto Islands where the boats have been pushed out and we use the boats and the docks as the anchors, vegetate the shorelines with walkways, and create coastal marsh or linear coastal marshes all along those areas.
That's wonderful. Very helpful. Thanks, Ralph. And that is the end of our Q&A for now, but we will be re-inviting Ralph for the panel discussion at the end. So please do keep your questions flowing. Let's now take a 5-minute health break to refresh before our last set of presentations before the panel discussion. And we are back. Next, we will hear from Paul. I will now invite Paul to share his screen while I provide a brief introduction. Paul Biscaya is a senior coordinator of wetland restoration at Credit Valley Conservation. He came to Credit Valley Conservation in 2008 as the authority was developing a formal wetland restoration program. And now he coordinates the delivery of this program throughout the watershed. And Paul, I see that your slides are up and in full presentation mode, so I'll pass the floor to you.
Thanks for the opportunity to speak today. I will be delivering a presentation on coastal wetland restoration and creation in the Credit River watershed, and showcasing two projects, the Rattray Marsh Restoration Project and the Jim Tovey Lakeview Conservation Area Project. And you'll probably see some parallels to the work Ralph just presented. For those of you who aren't familiar with our watershed, this map here sort of depicts our jurisdiction. Essentially, the Credit River starts in Orangeville, just a little bit north of the Island Lake Reservoir, and discharges in Mississauga at Port Credit into Lake Ontario. We've had a look at our shoreline through a Lake Ontario integrated shoreline study, and broke the shoreline jurisdiction up into 7 coastal reaches. The areas we're going to be focusing on today are reach number 5, Rattray Marsh, and the west end depicted by the red star on this slide, and the Jim Tovey Lakeview Conservation Area being reach number 1 in the east end of the jurisdiction, very close to the border of the Etobicoke Creek watershed. So on to Rattray Marsh and the work that we've completed there a few years ago. So for those of you that don't know Rattray Marsh, or I think some of you may on the call have probably seen me present on this particular project as well. It's a a Baymouth Bar coastal wetland. It's the busiest conservation area we have in our watershed. We see well in excess of 1 million visitors a year without formal parking. A lot of that is the community, but a lot of it is also associated with the waterfront trail and access at different points there. In 2008, CBC got marching orders from Hazel McCallion, the story always goes, to start looking at Rattray and some of the concerns that the residents that frequent the CA a lot were having with the particular property around what they perceived as the loss of open water and vegetation in the submergent portions of the wetland. So we undertook an MNRF Class EA process to look at restoration options, and found that the marsh was suffering from all the usual suspects that a coastal wetland would: changes in flow and water quality associated with urbanization, erosion from Sheridan Creek watershed upstream, as well as exotic species such as carp and Phragmites that others have touched on as well. So those historic land use changes, this photo is in the 50s. You can see there's a tiny bit of urban development to the west and east, but largely the land was cleared for agricultural purposes. And then coming into the modern day post-restoration, a lot more urban development upstream. Portions of that agricultural development around the wetland had naturalized, given that it was sort of the property itself was put into a protection by a private citizens group who purchased it, and it was subsequently acquired for management by Credit Valley Conservation. So in this slide, you're seeing the Sheridan Creek River delta cutting through to the Beachmouth Bar, but a lot of that vegetation on the screen outside of the forested areas is Phragmites and cattail. So we initiated the study by, first, we were pretty sure there was issues with sedimentation given the sub-watershed that the wetland sits in. So we underwent a soil coring and sediment deposition study. And what we found through that process was that there was a persistent layer of sediments on top of an organic layer of soil that we thought, in conjunction with carp and invasives, was impacting the water level, the depth of water, because of it being there, and the ability for submerged aquatic veg to grow. So we came up with a restoration plan that essentially primarily was looking at addressing that sedimentation and invasive species concerns in the wetland. And then the second part of that work was, how are we going to do it, given we anticipated it was quite going to be quite expensive, given there were also contaminant issues with some of that sediment from past land uses, and we'd have to dispose of it in a confined disposal facility. So what we did was came up with a phasing plan, which initially was quite extensive. All of these polygons on the screen were cells that we could take on and in an individual way as we were able to generate funds for the work. And fortunately, people took interest in the project, and we were actually able to do it in 2 years. So 2 phases, the first phase being the purple polygons and the second phase being the orange polygons. We removed about 3,000 cubic meters from the first phase of the work, and about 5,500 cubic meters of sediment from the second phase of work. And the yellow green line, I'm not sure how it's showing up on everyone's screen there, was the methodology that we came up with to access the marsh, which was a little contentious, given we were working in a provincially significant coastal wetland. So essentially what we did was we utilized conventional construction techniques. We built a road to get out into the wetland, to be able to allow access for excavators and rock trucks to implement the grading plan for the project. It was basically built on filter fabric, woven geotextile, like a hard plastic snow fence sort of, and a clear granular stone, so no sediment in it, and built up to about 1 meter in height. And then with the intention of it being used in the winter months so that we could use excavators and rock trucks, like I mentioned previously, to do the work. We were fortunate. The winters of 2014, 2015 were very harsh winters. So the contractor was actually also able to utilize ice in the upper right-hand corner, minimizing the amount of granular material we need to import and export out at the project conclusion, and steel plates as well to get across Sheridan Creek to access the second phase of work. So you can see the exposed organic soil, and the two slides here are survey data was quite accurate for the most part. There was a bit of time passed between study and project initiation, and a bit of the surveying data was off in phase 2, but we were able to rectify that during the actual construction and just refine volumes and grading then. And so this is a pre and post restoration shot showing the phase 1, the portion, the cell in the north, after we had regraded, got rid of that sediment, excluded carp. The left is the pre-construction conditions, turbid, not much in the way of visible submerged aquatic veg, and on the right, a much better water clarity and almost 100% coverage of submerged aquatic veg there after exposing that buried seed bank. So in terms of ongoing management at this particular property, we continue to manage for carp. We manage 2 welded wire carp barriers that isolate the northern and southern basin. I should update the image on this side to show current conditions. Those are before restoration there. Annually, it requires some repair due to the flashiness of Sheridan Creek and ice coming down in the spring, as well as we've had a couple of high water years where, having increased the depth of the wetland, we haven't been able to safely work in there with our staff to repair it. So it does breach from time to time in terms of the fish. Similar to the other projects showcased, we do quite a bit of Phragmites control. It was a big problem pre-restoration here. We had the unique opportunity on the left to address some areas where it was moving towards the lake, but due to the depth of water and the restrictions around herbicide over water at that time, we weren't able to, it was all mechanical techniques, which were not proving to be overly effective, but we were able to, through the dredging process, mechanically, physically remove it from those areas. In addition to that work, we are also doing sediment deposition monitoring. We've adopted a protocol from the USGS service in the States that utilizes pins and benchmarks throughout the wetland, where we can go in with a total station and try and analyze the rate of deposition that's happening there over time, to also help with facilitating our watershed management team with a pilot project for developing a sediment deposition model for the Sheridan Creek watershed, which is looking at all the sources of sediment in the subwatershed and the sinks, how it's moving through the system in the floodplain, how much of it's being stored in the channel, and ultimately winding up in Rattray Marsh, with likely the primary focus being, in terms of how it's impacting Rattray, is hazard mitigation in the upper water, erosion hazard mitigation, excuse me, in the upper watershed, to try and prevent that same condition from occurring again, or at least slowing it down. The work was quite expensive, so I always like to, and I think at the beginning seemed almost impossible, with things like building the road out into a really high profile area for us. The first phase of work was about $700,000, and the second phase being about 1.4 million. But none of that would have been possible without all of these project partners that we had to make it a reality. So now a very different project, but similar to some of the work Ralph showcased. It's the Jim Tovey Lakeview Conservation Area, where we're looking to create more natural habitat on the Lake Ontario shoreline, where it was lost due to again, the usual infilling of the shoreline, urban development, and things of that nature. The concept from the project came from this man. This is the late Councillor Jim Tovey. He was a former CVC Board of Directors member and the councillor for Ward 1, the area where the project is and is taking place. He was a real champion for this particular work, and I don't think we would have it would have been as successful in terms of the community acceptance for it without his help. The whole area is undergoing quite a transformation. This is the GE Booth wastewater treatment plant, sort of in the center of the screen here, but to the left where you see the stylized Lakeview icon, that used to be the coal power fired generating plant. I think they were called the Four Sisters stacks, or Three Sisters. I can't remember how many of them were there. But that is being revitalized into a community that will bring 20,000 new residents to that area. In conjunction with the Lakeview project, there will be increased connectivity with the waterfront trail, the yellow dot lines, for the surrounding people through more of the adjacent conservation areas along our shoreline. In terms of gains, the project, there's the existing habitat pre-restoration in that geomorphic on the Mississauga's waterfront. But in terms of what Jim Tovey Lakeview represents for this portion of the shoreline, is the landform itself is 26 hectares in size, and we're recreated about 7.7 hectares of new coastal wetland in an area where none previously existed. So this is the landscape plan or rendering that was taken to the public based on their input and the work of the design team. You can see the Sursen wetlands to the east of the project, and the Applewood wetlands that we'll be showing you on the very west end of the landform, as well as all of the other habitat features, the forested communities, meadows, islands, and cobbled beaches. So similar to what Ralph showcased there, this type of project is the lake filling project is done via the creation of a series of containment cells, and then a fish rescue is completed within that area and the filling proceeds. And then the landscape is sculpted for all of the topography for the various features and naturalized as you move along. So this is just showing the different cells and progression of how the construction is currently going. So in the upper left-hand corner, we have the site prior to very little fill being put in. They're just starting the construction of the containment cell that you can see in the upper right and the bottom left. And then the bottom right-hand side of the screen is how the progression for the restoration would go. This is the Sursen West wetland. You can see at the bottom, as well as some of the meadow habitat that is being restored in sequence with the development of the construction. Same shot of just from a different profile on the left. You can see the areas that are being naturalized. To the right of the Sursen wetland, you can see a pile of logs. That's all the habitat that TRCA is installing on our behalf in there. I should have mentioned it's a partnered project between Region of Peel, TRCA, and CVC, with TRCA doing the hard construction, and the sort of oval area that's delineated by a sediment erosion control fence would be the other half of the Sursen wetland that is yet to be constructed. So as the features were being built out, we knew we had a lot of naturalization to do given their new landforms, and we put out a tender for a very large aquatic plant growing contract in advance of the work, which was won by St. William's Nursery. It was just shy of 80,000 units in total for the naturalization, and they were growing that stock out and collecting seed and things depending on how you propagate the particular species about a year in advance of the work that we'd be completing. So similar to what Ralph showed, we also utilize the work done by the Canadian Wildlife Service and the different zonations in the Lake Ontario wetlands to develop our restoration and planting plans to help guide where we're putting those species and maximizing their success when they're installed. So the blue T-bars on the on the screen here would delineate the submergence zone. Green, typically where we're installing emergence, and then the orange bars, the wet meadow and more upland zonation for the components of the planting plan. So once the landscape is graded, all the habitat is put in, and it's yet to be connected to the lake. It sort of looks like this. And then we utilize snow fencing and filter fabric to install the plants in those cells. In some of the emergent cells, we will also use filter fabric to help with water quality. They're newly created sites. Sometimes some of the erosion control measures fail. We see turbidity out in the water, and we're interested in keeping the water as clear and maximizing light penetration to help those plants establish before that organic matter Ralph was talking about starts to develop and help with water clarity in one of his examples. The previous slide in the Sursum wetlands, excuse me, there was about 40,000 units installed in total. This was the Applewood wetland, which we just finished with the planting last year. Some challenges in sourcing plant stock last year should have been closer to 8,000 units that we put in, but really we were only able to source about 32,000 units from the grower due to some difficulties they were having with propagation. We think that's okay. We'll be doing things in the future, which I'll touch on, to remedy that and make sure the sites are inoculated with enough plant material to establish. So some of the results that we see right out of the gate, this is, installed soft stem bulrush in June, and what it looks like in a cell in terms of growth and establishment in August. Similarly, more of a deeper emergent cell with some lilies and things installed there. I don't know if you can see the sort of strings across the top. These are also to help water from keeping waterfowl from landing in the smaller puddle ducks and things and eating our plants. The type of growth that we're seeing in the meadow and riparian areas as well in the first season of establishment. In terms of ongoing management, we're continuing with invasive species. Phragmites is a bit of an issue here. So we want to get on top of that as their Applewood's quite new. The Sursum wetlands have been established for 3 years now. We are continuing with some infill seeding and infill planting. Maintenance of some of the planting enclosures. The ice beats them up a little bit, and the geese will be there soon again to start munching away. So we'll be fixing some of that up as the season progresses. And similar to Ralph showed, we have integrated, I think, a very similar style of carp barrier and water control management structure. I believe TRC, I believe it did happen. It's on our webpage. You can see they opened up Sursum West to the lake yesterday. So that's connected now, given that it's had 3 years to establish. And I knew I wouldn't have time to showcase these videos in this presentation, but for those that are interested when it's circulated, the project, there was a really interesting process in the design of the project where a 1:35 scale model was built, and you can watch a lengthy YouTube video of the landform at the National Council of Canada. And what that allowed us to do is look at the landform in the context of different lake water levels, storms, direction of storms, wave heights, and things like that. It's really just a big model in what looks like a swimming pool with all sorts of wave machines and fans to simulate a scaled down version of what it would look like. And it resulted in, I think, a pretty significant cost savings in terms of the engineering and stone sizes and things that were required to armor portions of the project that needed protection from the lake, given it was all open coastal habitat, as well as a few videos that were developed as part of a Society of Ecological Restoration restoration series that was done online during the pandemic there. And then again, the project partners that have all been involved in making this a reality.
Thank you so much for the great presentation, Paul. It's so exciting between your presentations, Ralph and Laura and yourself, to see so much great work taking place on the ground. I'll pose the same question I posed to Ralph. Where would you like to see the restoration and adaptive management of coastal wetlands go next in CBC?
I think in the context of Rattray, I'd actually like to see it in the upper watershed. I think that's where some of the stressors that are impacting it the most can be remediated. So through this sediment deposition model, if we can identify areas of high erosion risk that might be like anthropogenic in nature, that prevent that type of infilling of the wetland that might be in excess of what is natural, would be beneficial. And also perhaps some of the water quality monitoring. Sheridan Creek in particular is the salinity is quite high at times of the year, and I think the marsh itself could benefit greatly from those types of improvements. And then to echo Ralph's point, in some of the other systems where they've been altered so much, the river mouths. Yeah.
That's great. Thanks, Paul. And we have a question from Emily. Emily is wondering if carp barriers interfere with the movement of native fishes.
In the Lakeview example, the spacing is about 2 inches, I believe, on center of the bars. So more laterally compressed fish and smaller fish can get in. Similarly, in the work that we have done at Rattray in the welded wire, much simpler. We're just cutting that same spacing into the welded wire where we install it. And we know as the marsh draws down, there's certain areas where the water is deeper, and we try and place them strategically there. And on those particular fences, we know carp and bigger fish breach it. We've also got one-way doors, which if you think of, if any of you were in 4-H or something when you were kids, call them bunny clips to make like cages for rabbits and small animals. And we just, the door will swing open one way, basically with a small, simple hinge. So it'll swing out into the Sheridan Creek Delta, but if a fish is pushing on it this way, they can't get in. And we have actually got some images of, it's a turtle or a carp. The water is moving in still water, but being utilized push through, and even wildlife, ducks, raccoons, and things using those strategic exits.
It's very interesting. Thank you for that, Paul. And we'll take one more question before we move on to Pete. So this was from Ryan, which I will pose to you. Ryan is wondering if you have any techniques that you prefer to use for establishing emergent vegetation in deeper water in situations where you are not able to control water levels.
We've had challenge. It depends on, I guess, your stock and if you're how big it is when you're able to source it as well. Like we've had that same challenge where if it's very small, it's not very successful. But targeting the I always get the zonation mixed up. But that sort of 74-8 in Lake Ontario, that 75 zone seems to be the sweet spot, I guess, for lack of a better term, for getting it to establish. And then if you had the good fortune of being able to regulate that water level, similar to what Ralph was describing, would be beneficial as well. But it is difficult in deeper water if you can't regulate it or have small plant stock.
That's great. And Ryan, I hope that was helpful. And thank you again for the great presentation, Paul. We will re-invite you to join us for the panel discussion at the end. And now I will just invite Pete to join us. Pete, please go ahead and share your screen while I provide a brief introduction. So Pete Zuzik received his Bachelor and Master of Environmental Studies from the University of Waterloo, specializing in coastal geomorphology and geology. He is a certified floodplain manager and a professional geoscientist. Pete has 30 years of consulting experience managing multidisciplinary investigations across the Great Lakes and the world's coastal regions. Welcome, Pete, and thanks for joining us. I see that your slides are up and in full presentation mode, so you're all good to go.
Okay, well, thank you, Sharon, and good afternoon to everyone. And certainly a pleasure to be here. And I think we're going to go on a little different tangent here now, because we're going to talk about protecting littoral cell geodiversity and restoring barrier landforms. And a lot of what I'll talk about today pertains to more natural systems in the Great Lakes, are more sediment dominated systems versus the Toronto waterfront. So it'll be a nice complement. And then, of course, some of the things we'll talk about are things we need. And we're going to hear Josh talk about what the Army Corps has done in the US to get us there on the last example. So I'll just jump into the slides here. But before I do, of course, there's lots of co-authors and lots of contributors here, and lots of people have funded the collection of this work that I'm going to present today. So geodiversity, geoheritage, and geoconservation. So what do we mean by this? That it's a concept that's become quite dear to me, and I think it embodies a lot of things that are really important in the Great Lakes. And geodiversity is essentially the variety of rocks, sediment, landforms together with the natural processes that form and alter them. Geoheritage then, of course, are those elements of geodiversity that are considered to have significant value for intrinsic, scientific, educational, cultural, spiritual, aesthetic, etc. So important places, sometimes just important because they're amazing physical landforms. And then geoconservation, of course, is protecting and managing geoheritage. And so a concept that I've been talking about for a long time now, and very relevant here to our shorelines, the Great Lakes, and our barrier landforms and the wetlands behind them, then are littoral cells. The diagram here on the screen is a conceptual diagram. We could take a map and divide all of the Great Lakes into our cells. They typically have boundaries, hard or sometimes fluid, semi-permeable boundaries. In this particular example, we have sediment moving away from a divergent node where we have a cell boundary, sediment moving to the east, driven by the long fetch of the waves here. And then as the shoreline orientation changes, we have a depositional environment with a decreasing gradient and sediment transport. And of course, behind these depositional features, we have the amazing coastal wetlands we find throughout the Great Lakes. And that diagram, of course, is patterned after Long Point. This is from one of the reports produced for Environment Canada recently. If we look at this whole littoral cell, we know quite a bit about it now. Relatively large portion of it, the yellow line here, is still in a natural state, only 6% hardened. So that's relatively low compared to other places in the Great Lakes. But what we also know now is that these three harbors, Port Stanley, Port Bruce, Port Burwell, have trapped on the order of 18 million cubic meters of sand in their harbor fillet beaches. And so that is a huge disruption to the natural flow of sediments and the sediment that ultimately moved to the east and built the Long Point landform over time. So the next map here is highlighting some recent work we were able to do with Canadian Wildlife Service, looking at the whole Long Point system, the whole spit. And there's a lot of things going on here, but in essence, just sort of focusing in on these purple boxes. We've subdivided the entire spit into a series of reaches, and we've looked at the change in the shoreline position from 1964 to 2020, accounting for areas that are eroding. And anything that's eroding, of course, are places where the barrier system's migrating inland and we've permanently lost our coastal wetlands. And so everything here at the proximal end of the spit, reach one, we've lost on the order of 50 hectares of coastal habitat, most of that being coastal wetlands in the last 50 years or so. We've lost a lot of beaches in the middle, but then if we jump over to the center portion here, the Long Point Company in particular, we've lost 200 hectares of coastal wetlands in the center of the spit due to erosion. The Long Point Company shoreline is eroded over 300 meters since 1964. So these disruptions that have happened in this littoral system and the disruption of the natural sediment delivery processes is having a direct impact, of course, on Long Point, and then on the loss of these coastal habitats that we value so much. Another Lake Erie example here, Rondo, where we've done lots of work. Greg has too, of course, and others, and just quantifying shoreline changes. And this is really a product of a number of different studies. We have a federal navigation channel here that's had structures since the early 1800s. We have a pretty accurate shoreline here from 1868 to look at changes. This federal structure has trapped sediment on the updrift side and created this landform on the order of 60 hectares, but at the detriment of the provincial park. And if we look at just 1868 to 2020, we've lost on the order of 200 hectares coastal wetlands in the lake due to erosion. And then because the barrier system is so degraded and there's wave energy now making through that system, through that barrier times, we've lost another 300 hectares of wetlands inside the park itself. So I know that this some numbers presented a little bit earlier there. These have just been updated. So we've lost since the sort of mid 1800s, 500 hectares of coastal wetlands here at Rondo because of the impacts of this barriers, the jetty navigation channel, and the fact that we've not mitigated those impacts. And then Point Pelee National Park, again, similar type of story there with Armoring Up Drift and Wheatley Harbor, a number that's a little bit maybe dated now. Point Pelee, last time we checked, lost on the order of 80 hectares of coastal wetlands along the east side, the erosional east side, the barrier system essentially eroding and rolling over itself into the marsh. And so there's another 80 hectares. And then the Hillman Marsh, which is something we're looking at too recently, just to the north, 1954, you can see the system with a natural barrier. Along comes a whole bunch of development, shoreline armoring, both sides. And we've lost the barrier during this latest high water period. And we've also lost all the coastal wetlands on the interior, with the exception of what's been protected with the dikes here, Ducks Unlimited involved with in the Conservation Authority here. Another just some quick math, 150 hectares of coastal wetlands lost at Hillman. So if we add all those up, rounding a little bit here, we get to 1,000 hectares of coastal wetlands lost in the last 100 years or so across the North Shore of Lake Erie because of modifications to our physical system, because we haven't managed the geodiversity of this system. And so touched on a few examples, but I want to go through a few more and highlight them. And this, of course, is in the reports that Greg mentioned at the onset. So we have provincial policies that facilitate shoestring development along the coastline. We really promote with our policies this, whether we want to admit it or not. We're driving development lot by lot along eroding shorelines when we could be doing things in a much more creative manner. We don't look at the incremental or cumulative impacts of development when we make regulatory decisions. And so shoreline armoring is a classic example. Look at thousands of structures and they've had enormous impacts along these shorelines. You look at a single one and they get permitted all the time. So not taking that fulsome system scale approach and looking at incremental and cumulative impacts is a big problem. And then armoring eroding shorelines with barrier beaches. And so this is the northeast corner of Point Pelee National Park. This is an erosional shoreline, and we can have barrier systems that protect our wetlands on eroding shorelines. But if somebody decides to hold the line, which we've done here because of the dike farmland, the barrier systems keep eroding on these natural systems, and that's a big problem, and often at an accelerated rate. All right, as far as some of the other things here, causes for geodiversity decline, we have not historically mitigated the impacts of sediment trapped at federal harbors. This is the example of Port Stanley here. The historical bluff is in this area. Again, over 4 million cubic meters of sand that's sitting here. Other jurisdictions, including the US, have ample programs federally to mitigate downdraft impacts because of harbors. And we don't do that in Canada, and that's an unfortunate situation right now. And then we have fractured management inside our littoral cells. When we looked at Long Point last year, we found at least 12 different types of landowners and at least 8 different management plans for one physical system. And so we don't take that broader scale systems approach or a littoral cell scale approach to managing our system, our coast, and consequently geodiversity is not considered. We have all this fragmentation and we have all this habitat loss. I should mention though, there's been some positive improvements lately down the Long Point region, so hopefully that will continue. Continuing here with some causes of geodiversity decline. This is one that is becoming more and more apparent to me as we keep doing work on other things. We're just finishing up a shoreline management plan for the Bay of Quinte and the Prince Edward County shoreline, so Quinte Conservation. over 500 kilometers of shoreline here where we're looking at the shoreline management issues. This is being led by Conservation Authority, there's municipal partners, and for whatever reason historically, because I don't really know what it is, the provincial parks, Sandbanks being a massive part of this system, and then we have Canadian wildlife areas here, Wellers Bay, are not part of the planning process. They don't get involved other than sitting potentially as observers, and we don't develop management plans for the provincial parks and the national wildlife areas, federal lands. And so again, we have an opportunity for everyone to work together when we do these shoreline management plans, yet we continue to operate in silos and we don't develop these fulsome recommendations for the entire shoreline. And that's a huge lost opportunity, I believe, and something we really should rectify. The graphic here on the right, again, Point Pelee, and just to highlight some of the issues here with what can happen when you unfortunately don't have a long history of integrating and managing with people. This is Point Pelee 3D rendering during average summer water levels, and this is what it looks like during the 100-year flood. So we've got some mounting problems here throughout these natural areas, particularly these barrier systems that are protecting coastal wetlands. And a lot of it is happening because historically, the various entities managing these areas have done so in isolation. Right, I don't want to only focus on Lake Erie. A couple of graphics here. This is the mouth of the Nottawasaga River, but another area, of course, it's causing this geodiversity decline. It's been touched on already. Our climate change. We've heard from Frank on Monday about projections of higher lake levels in the future. Obviously, continued variability, but higher highs is on the table. Ice-free winters. The graphic on the below is some work we're doing in Maitland Valley. We're looking at number of ice days historically along the shoreline, and go back to the 70s, early 80s, and we're up and around 100 days. If we ignore these polar vortex years of 2014, 2015, we're down on the order of 30 or 40 days. So we've already seen a dramatic reduction in ice cover, nearshore ice cover, which historically would protect our shorelines. And of course, with the warming we're all looking at, we know that's going to continue. So ice-free winters are going to be a huge driver of negative things. And that, of course, less ice cover in the winter means more winter storm exposure. So a lot of challenges coming, and you could argue they're already here with climate change. But look what happened to this coastal habitat here. There's some amazing panes back behind the dunes here at the mouth of the Nottawasaga. In a matter of 5-6 years, lost 100 meters of shoreline and coastal habitat during high water periods. So just a devastating impact to this really important wetland and dune habitat at the mouth of Nottawasaga. All right, so keep going on the declines here. We're going to turn it around soon and get some positives. So some other things we don't do enough of is collect data. We really are lacking behind other jurisdictions like Britain and the United States. Even the little tiny island of Barbados, which has a population of less than the city of Burlington, they've been monitoring their beach profiles since the mid-1980s 4 times a year. We don't even have a beach monitoring program in Canada and the Great Lakes. So this is a huge problem because we don't fully understand how these systems are changing. We don't do regional sediment management work. Again, something that the Army Corps has been pursuing and creating innovations on for quite a long time on the south shores of the Great Lakes. We're just not in that game, and we need to be. And then the other one that's really lacking, and it's a challenge here for all of us to change, is that we haven't implemented any large-scale sediment innovations. We've just not broken out of our comfort zone and done anything collaboratively to do something to solve these problems of reductions in sediment supply and reductions to geodiversity. And we've written about this for Environment Canada a couple of times now. The Port Burwell, I think everyone's probably well familiar with the sand engine, the Dutch sand engine. Well, we've got an example here where we could replicate that concept right in Port Burwell, upstream of Long Point. We've got over 12 million cubic meters of sand sitting in this harbor because it was expanded, the jetties, twice now on only one side, and there was no consideration given of bypassing, sediment bypassing. So the strategy, unfortunately, for a long time here at Port Burwell is just trap every blade of every grain of sand so it doesn't fill up the navigation channel. So we need to dismantle this jetty. There's no reason for it to be there. This used to be a coal port terminal. There's no coal port terminal anymore. There's no reason to be trapping all this sediment. If we did tear down that jetty, we could sell all the armor stone and pay for the dredging and put that sediment back in the system. So here's just an example of something that we could be doing in the future to help restore the geodiversity that we've lost. All right, so now on to some of the work specifically with Greg and others here, Anders, to come up with strategies. And so this number 2 strategy is restore geodiversity in littoral cells and restore barrier landforms. So there's there's 3 measures here. One of them, and I've touched on some of these issues already, update land use policies and regulations that negatively impact physical processes. So we have in Ontario a pretty robust legislative regime here for working along the shorelines. We have things in the PPS that say we shouldn't do anything to our shorelines if we cause negative or adverse environmental impacts. We have the Conservation Authorities Act that talks about conservation of land. And even the older Great Lakes Technical Guide speaks about not creating new hazards. The problem is we've never made these land use decisions through the lens of incremental and cumulative impact. So we have the right words in these documents and we haven't applied them appropriately. We definitely need to stop building houses on eroding shorelines. This is planning to fail. And permitting shore protection. There's other jurisdictions now, the Carolinas and Oregon, where shoreline protection structures are strictly prohibited. And we need to start thinking about that. We're falling behind other jurisdictions. I should say that in the report, there's lots of links and web links to people that are doing things differently to provide some context here. Integrating climate change into regulatory decisions. This was written about a year ago. Happy to report that we're actually working on that now with the province, Ministry of Natural Resources, to get climate change integrated into some of the regs. So that's a positive. Why only 100 years? Why not 200 years for our planning horizon? That would keep people away from eroding shorelines. This is a big one, and Greg and everyone else here from the federal family, we don't mitigate the impacts of littoral barriers. We need to change that. If we want to get serious about protecting our barrier systems, especially the ones on the North Shore of Lake Erie, there's so much trouble. The federal family needs to come together and figure out how we're going to mitigate the impacts of these structures. Lastly here, special policy areas to protect geodiversity. So this polygon, something we've been talking with Environment Canada about, 3 areas obviously I mentioned here, Long Point, Rondo, Point Pelee. We don't have the tools that we need to protect and manage these areas and restore geodiversity. So if we don't have the right tools, we need to have something we don't have yet. And this is something that needs some more consideration and thinking about how important the physical processes are in those littoral cells across the North Shore of Lake Erie. If we don't have the right tools now to protect them, then we need to find a way to get the right tools. And then finally, we need to create incentives for managed retreat versus shoreline armoring. All right, so that's a lot of things here on the legislative front. Number 2 here was develop integrated littoral cell management plans. So it's a topic we've been talking about for a long time. I won't go through and read all this, but in a nutshell, we need to start managing our coastlines in the Great Lakes at the physical scale that processes are happening. That's littoral cells. And that means an all government approach. It means everybody, not operating in silos, not managing fish and birds and ducks differently. It means managing it as one integrated system, pooling all our resources, our knowledge, our talents. So this is desperately needed. And if we don't start doing this, we're going to keep working in our own little silos, our own little sandboxes, and all the things we value, like the wetlands, are going to keep disappearing. All right, on to keep going here with reestablishing sediment supply. So if we want to protect and restore geodiversity in our barrier systems, we need to find ways to bypass sediment at harbors. It doesn't have to be trapped. It's done all over the world except Canada, and we need to figure out a way within our government regime to start bypassing sediment to where it needs to go. the Port Burwell sand engine would be an incredible project to design and implement, and one that could really pave the way for other nature-based solutions in Canada. And I think it'd be an awesome one for us all to think about how we can actually make it happen. Nourishing and literal cells from upland sources. Again, we don't really do that. I'm not sure why. Presque Isle in Pennsylvania has a massive program where sand's trucked to restore beaches on an annual basis. We could do more of that. And then another concept that's applied elsewhere that we've never got into on the Canadian side is backpassing. Sediment is moved and removed, and it'd be great if we didn't have to think about these complex engineering projects to save our beaches. But the reality is we're at a point in time now where we need to. And places like the shoal off the tip of Point Pelee National Parks holds millions and millions of cubic meters of sand that could be moved and put back on the beaches to restore these areas and protect them in a natural way with the help of the engineering support. So these are all ideas that we're going to have to start to embrace if we want to restore geodiversity and protect our barrier systems. And then lastly is projects at the local scale. So sort of zooming in, localized beach nourishment projects, wave attenuation structures, dune restoration. These are all things that could be done to start to restore and improve areas that have been impacted. And just a couple thoughts here on Hillman. I talked about it a couple times. This is a 2020 ortho. So this barrier system is completely breached now, 600 meters in the middle. We've come up with a concept drawing of what it would take to put the barrier system back. And this is very much a heavy construction project at this phase, if it was ever to proceed. So this is just the engineering components, not the restoration of the wetlands, et cetera. It's a series of islands, shoals, beach nourishment to realign the shoreline back in a stable location. It's just simply got too deep here that you could never build the barrier back where it was historically. Whether this is appetizing or not, I guess is a debate for people. The reality is we don't have a barrier left, so we have no choice. But the other important context here is that barrier that's gone now, to put it back, just to engineer something back would cost on the order of $10 million. And that's not including the cost of any restoration work. So these systems that are all degrading, to put them back, and Josh is going to talk about a similar example there at Braddock next, it's a lot of work, a lot of innovation that's needed, and it's really expensive. So if we could avoid doing that, that would be obviously far better. And so just a couple closing thoughts here, Sharon, I'm almost done. I just want to talk a little bit about the future and the future of geodiversity in the Great Lakes and the wetlands, and what is it going to look like? And I guess the question is, are we going to protect it, or are we just going to have a completely altered landscape? So just a few thoughts here, trying to broaden our thoughts a little bit and maybe queue up some questions and discussion. I had a chance to listen to this, a really interesting webinar by Emma Morris from University of California, San Diego, Institute of Practical Ethics, that's really why I started watching it, because it sounded so interesting, practical ethics. But she had a talk here about the future of nature, conservation in the Anthropocene. And there's a lot of really important messages, but one of them, and I think this is really relevant to our wetlands and our barrier systems and our geodiversity in the Great Lakes, is that these ecosystems we care about and the species composition is changing. And I think we all know that, and it's going to continue to change. And because of that, she sort of stepped back with her work and presented three ways to think about resource management, conservation, biodiversity, geodiversity protection. And I thought these had a lot of, again, for me, they helped sort of organize my thoughts a bit, getting this slide deck together as to what we can do moving forward in the Great Lakes. And so the one approach she refers to is observation zone. And if an area, a natural area, is considered to be under the observation zone approach, we're only going to observe, we're going to let nature take its course. There'll be no management actions. And you could argue that's what we've done historically with geodiversity in the Great Lakes, where we've not really done anything to try and stem the tide. We haven't tried to protect it. So we've really done nothing. And you could argue we've actually taken negative actions. And then we have the restoration zone, which would be areas that are heavily managed to avoid decline below historical baselines. And so we do this in our natural areas now, where we've set out targets for what we think our ecosystem should be like, and we want to make sure that they don't go below that historical baseline. And then she talked a lot about this innovation zone. And in her mind, this is where new innovative actions to preserve high value natural areas are tried. And she also talked a lot about accepting the fact that we're going to have novel ecosystems that are going to be the reality in the Anthropocene. We cannot protect everything at the historical baseline. Things are going to have to change. You can look at all that great work on the Toronto waterfront that's an example of that. We're going to have to experiment. We're going to have to get innovative and try things and use that adaptive management concept. And so I thought this was interesting because I think what we've really done with geodiversity is just observe and watch it go in decline, and thus the wetlands too. And what we really need to do is move down to these other two concepts, which is restoration and the innovation zone. And just the last slide here, another thing I hope that will just help provoke some thought and discussion. There's an interesting paper by a colleague I worked with, Michael Risk, from retired geology professor from McMaster. A lot of great work on stable isotope analysis and coral reefs and other environments. He wrote this paper, and if anyone that knows Mike, he's as brilliant as he is, he's also really controversial. So he wrote a paper 1999 entitled Paradise Lost, How Marine Science Failed the World's Coral Reefs. And I won't go into any great detail about it, but there are some important takeaways in this quite scathing report in this paper that he published. And simply was that after 20 years of identifying the major stresses on coral reefs, pollution, overfishing, there was no response model to address the stressors. We didn't come up with a plan. What we did though, throughout the coral reefs of the world, is that rather than building again a multidisciplinary set of teams to deal with the stressors, we focused on monitoring really across the reefs. In his point, the biology disciplines focused on monitoring swim transects of what was happening to these reefs, and all we really did was monitor the decline. And 20 years later, we had no plan, and we had some data that, and he would argue, we don't even know what we're going to do with. And so I guess the point I'm trying to raise there is that, Greg, throughout this enormous study you've done, we're now sitting on a lot of information, and we need to transition into action. And my hope would be that we don't need to write a similar paper entitled Paradise Lost, Great Lakes Coastal Wetlands. And the goal here, I guess, is to move beyond the study now and take action. And just a couple things, though, to sort of highlight how long we've known about the need to do integrated coastal management in the Great Lakes. In 1973, we had a document called the Canadian Ontario Great Lakes Shore Damage Survey. It recommended developing coastal zone management plans in the Great Lakes. We fast forward to 1981, Great Lakes Shore Management Guide recommended the creation of shoreline management plans to reduce flooding, protect social values, minimize adverse environmental effects. So those things started almost 50 years ago. There were important pieces of work that were authored by Fisheries and Oceans, Environment Canada, Ministry of Natural Resources, but we've yet to take the action. We've yet to move forward and build the multidisciplinary teams we need to start solving some of these problems with geodiversity in the Great Lakes that are so critical to protecting the wetlands that we value. So that's my final slide. Hopefully it's a bit of a conversation piece that we can talk about, and I hope it will be a call to action moving forward.
Thank you so much, Pete. Lots of important food for thought and calls to action. Unfortunately, in the interest of time, we do need to move on to our last guest presenter of the day, Josh. And this will unfortunately take us beyond our allotted time. So I understand that if you need to leave, we will make a recording of today's webinar available in a couple of weeks following the webinar series. So with that, thank you again, Pete. And I will now invite Josh. I see that you have your slides up and running. I will just briefly provide an introduction. Joshua Ungeier is a restoration ecologist and plan formulator for the Army Corps of Engineers, Buffalo District. He has over 15 years of professional experience in the environmental field with positions held in the academic, private, nonprofit, and federal sectors. In his 11 years with the Corps, he has acted as a technical lead for ecological restoration projects, addressing coastal, riparian, fluvial, wetland, and littoral systems. Josh, I see that your presentation is up and ready to go. I'll pass the floor to you.
Sounds good. Thank you very much. And thanks for having me here to present on this. Really grateful to be here. The presentation so far have been phenomenal. And it's just incredible to see this exchanging of ideas and experiences and knowledge and data to such a broad audience, and I really am grateful to be here and share some of our experiences at the Corps at this site at Braddock Bay. So with that introduction, I'll be discussing the Braddock Bay Ecosystem Restoration Project. There's many partners to mention here, but I'll just name a few. This project was funded through the Great Lakes Restoration Initiative by the Environmental Protection Agency, GLNPO office, so Great Lakes office. We partnered closely with the New York State Department of Environmental Conservation, the town of Greece, and received sort of phenomenal technical support and advice and expertise from State University of New York in Brockport. And there's a bunch of other partners to mention, but I'm going to jump right in and talk about this project here. So Braddock Bay, real quick, is located on the southern shore of Lake Ontario. It is to the northwest of Rochester. It is part of a wildlife management area, which consists of several drowned rivermouth type ecosystems. Up until our project, Braddock Bay was the only one that was open and exposed to the open energy of Lake Ontario. But that was not always the case. When we started looking at the project with local partners, we dug into historic navigation charts and historic photos going back to 1902, and we identified that historically Braddock Bay was an enclosed system. It had like that's been discussed several times, a barrier beach system, a spit of sand that existed in the mouth of the bay, protected it, maintained it as a low energy system, protected the emergent wetlands within. But as a result of a lot of shoreline hardening that happened on the southern shores of Lake Ontario, that littoral system was affected. The amount of nourishment the beach received decreased. And we started seeing declines in that barrier beach according to those historic photos by the 1920s and 30s. By the 1950s, that barrier beach was almost completely deteriorated, and the bay had converted more to an open water system. That was associated with a loss and decline of wetlands. We did some evaluation of that. I don't really show it here. I didn't have really time to jam it in here, but we showed that over approximately 100 years, since the early 1900s, so like 1915 to 2015, there was about 106 acres loss of wetlands from Braddock Bay. And so the whole system changed from being this enclosed system to an open system. Other issues that resulted is high turbidity in the bay. Also, littoral sediment, although not enough to really rebuild the barrier beach, was accumulating inside the bay. So it was kind of filling it in. It was getting sequestered. That littoral sediment was getting sequestered in the bay, and so then not able to move further down on the shoreline. And so, meeting with our direct partners and a whole group of stakeholders, we had a lot of meetings to discuss different approaches to how to restore some of these issues. And one other thing I forgot to mention, but that in addition to the loss of wetlands at Braddock Bay, there was also a decline in their quality. Again, historic photographs showed historically those Braddock Bay wetlands were diverse emergent marshes and open water areas. However, as a result, shortly after some of the changes in lake level management, a lot of those open water areas filled in. And by the time we got to the project around 2010, 2015, it was primarily a monoculture of invasive cattail, hybrid cattail, Typha glauca. And so our goals for this project were twofold. We wanted to reduce the erosion, the erosional loss of the Braddock Bay wetlands, while improving the diversity of wetlands present and the quality of wetlands present. And so with our partners, we developed a design to do that. And we had a lot of different alternatives that were discussed, but ultimately we came upon this design, which had four major components. They were restoring a barrier beach to function similar to the historic barrier beach to protect the bay and reduce wetland loss. Excavate channels and potholes in the existing wetland to open them up, allow access of native fish into the marsh, into the remnant sedge meadows that were there, and also create a diversity of habitat types. Treat invasive species, primarily ones we had here were Phragmites, but we also experimented with treating some areas of the Typha glauca that was adjacent to the remnant sedgegrass meadow to see if those areas would expand. And lastly, after reducing wave energy in the bay, we wanted to try to restore some of the emergent wetlands which were historically there. I'm primarily going to talk about those two first components today. That's where I'll spend the majority of my time, but I'll mention the other ones briefly. And again, some of our other partners that assisted with this were the Town of Greece, the New York State Office of Parks, Monroe County, and the United States Environmental Protection Agency. I'm going to start with the barrier beach. So again, the objective here for this project was twofold: reduce erosional loss of the Braddock Bay wetlands and improve their quality. And so we set out to try to design something that would help reduce that erosional loss, reduce wave energy into the bay and the associated erosion of wetlands. But we didn't want to stop there. We also wanted it to intrinsically provide its own ecological habitat. So we didn't want, we discussed a variety of options, including just, a standard break wall. But what we decided with our local sponsors and partners and stakeholders was that we wanted something more. We wanted something that was alive, something that contributed habitat, something that also worked with the existing littoral processes. And so this is what we came up with. We designed this feature that is, we consider it nature-based because it's intended to function, to have those natural functions that the historical barrier beach did. It's intended to provide beach habitat, shorebird habitat, as well as some other vegetation types such as upper dune and scrub shrub. It's intended to help maintain those historic littoral sediment transport processes. So like I mentioned, sediment coming down drift was just sort of getting trapped in Braddock Bay. It was getting pushed in. It wasn't enough to naturally rebuild that barrier beach. It was just sort of filling in the bay, and it was keeping it from bypassing the bay and getting further downstream. And so we wanted to design this in a way that would help keep that littoral sediment in the littoral zone so it could bypass Braddock Bay. And ultimately, we wanted this what we built to be resilient to the variety of conditions on Lake Ontario. The first presentation talked about what is resiliency, and I think it can mean a lot of things, but we definitely know when our coastal shorelines are not resilient. And in prior to this project, Braddock Bay wasn't. Ongoing wave energy was eroding wetlands, and the system was in a state of in unequilibrium. So let me dig deeper into, so those are our main goals for the barrier beach. This is what it looked like at construction, but let me dig into some of those components. So it consisted of basically three things: large stone, 3-foot diameter stone, and that was needed so that ice forces and waves forces didn't destroy this, didn't move it out. a lot of sand, most of which was dredged from the mouth of Braddock Bay using a hydraulic dredge method. So we used on-site sand that was sort of sequestered in the mouth of Braddock Bay and used that to build and nourish our beach. And we actually overbuilt it. We overfilled it so that we wouldn't be trapping any sediment in the littoral zone that would be after day one contributing. We knew a lot of it would erode away, and so we would contribute to that littoral sediment transport. And lastly, we also included plants. We wanted to plant it. We wanted to make it alive. So this truly was, as I consider, a natural, a nature-based feature, or what sometimes we call a green to gray hybrid feature, because we did need to use large stone to hold everything in place. We actually did look at what would happen if we just built this thing out of sand. It was going to be actually more expensive, and when we sort of plug this into some of our models, it was determined that it wouldn't really be resilient even over a 10-year period. It would rapidly sort of degrade, sand would be pushed into the bay, making sort of the condition in the bay worse, and it just wouldn't hold up. So we determined we did need to use a large stone to form the structural backbone of this feature, but that we could make it also provide the ecological habitat that we wanted it to intrinsically have. And so in addition to a 1,675-foot breakwater at the so rubble mound breakwater, that was sort of the spine. It was at a crest height of 6.5 feet. So for my friends in Canada, I can't do that conversion on the top of my head, but it was 6.5 feet above low water datum. So plug that conversion in. That was the backbone, and then that was augmented with two short terminal groins, 180-foot terminal groins, and two headland breakwaters. These right here are the headland breakwaters. They are spaced about 200 feet from that spine breakwater. What that did was it created an open yet mostly protected area in front of the spine breakwater that we could maintain beach habitat. Okay, this provided us an area that we could fill with sand, and the sand wouldn't immediately erode away. It would remain resilient, and it would stay in place despite the high diversity of water levels on the lake. And so that was, one of our first green components was application of the sand to create this beach and create this habitat. We didn't stop there though. We also wanted to create some vegetated habitat. We wanted to, rather than just having stone, we wanted to cover that up. We wanted it to be alive. And so we choked the large stone, the void space of the large stone, with more sand dredged from the mouth of the bay. That allowed us a planting media that we could install native shrubs in and plant and vegetate the backbone of our structure. So that way we would have a transition from sort of open beach to grassy and shrubby upper dune to this sort of crest, which is a mix of shrubs and grasses. And after construction, this is what we had. So construction was in about 2018, it was completed. This picture is from 2 years later, but is representative of what we see out there now. And we've had three distinct coastal habitats develop on this barrier beach. We get the open beach, the sand, lacustrine open shoreline near the water. And again, this is accessible shoreline. This maintains the transition zone between the open water and the beach habitat, and that swash zone is still intact. The shorebirds really like that. So that was important. That was allowed because we had those headland breakwaters that were helping to keep the sand in place, but there were spaces between them, which allowed for that accessibility to the beach. On the upper dune, we get a mix of bunch grasses, switchgrass, some shrubs like dogwood and willows. And we've also got a lot of natural recruitment of cottonwoods. And then sort of by itself, naturally, in the protected area behind the beach, we just naturally got this establishment of emergent marsh species. So we have some polygonums, some smartweed, some scirpus, and some cattail has accumulated back there too and is getting established. But we do maintain those three distinct coastal habitat types with our design, and they're functioning really well. Just some data here about the type of species we're seeing with the help of New York State DEC, who's who's a main partner in this, and SUNY Brockport assisting them with some of the monitoring adaptive management. We've seen some really good results. We've seen 26 different species of shorebirds using the barrier beach since its construction. This includes some endangered and threatened species also, including the piping plover and the red knot. Some other fun numbers also, in 2020, in November of 2020, there were 100 dunlin sighted that sort of stopped over and were present at that barrier beach for over a week. And in 2019, we had a big flock of semi-palmated sandpipers observed in a single day. And that's associated with all these other counts of species too. So this has become an eBird hotspot. And it's also supported by our data, which shows a lot of usage from a lot of shorebird species. So it's looking really good. Sorry, son just got home from school. Sorry, buddy, 1 second. And so we're seeing a lot of species usage. Our target species for the barrier beach, those shorebirds, looks really well. It's doing really well. In terms of is it resilient? So we had a good way to test that. And that was the record high water levels of 2019. So we had record high water levels in 2017, delayed the project. We got to finish it in 2018, and shortly after, we had basically water levels almost to the top of our crest, right? They were almost at +6 feet, +6.5 feet. So that made us a little nervous, but when we went back and looked the next year, we were very happy to see that our structure held up, that those headland breakwaters, those sort of segmented breakwaters that were 100, 200 feet off the main spine breakwater, they did a good job at retaining sand. We do get large tombolas forming between them, which was as expected. Those are the unprotected areas. But that's okay. We didn't really see a loss of our total extent of beach. We have some localized scour in those tombolas, but our beach was intact. Our habitat is still there. We still get our different distinct habitat zones created. And so it appears to be really resilient to the fluctuating lake levels of Lake Ontario. So that's good. Really quickly, some lessons learned about the barrier beach. I'll cover those just real quick. It seemed to work really well at providing ecological habitat and also converting Braddock Bay back to a low energy system and protecting the wetlands within. We've also seen a lot of vegetation establishment along that spine because we choked the void space in between the large stone with soil. So that worked really well. There was some question on whether or not that would work, and it seems to have held it up. The vegetation did fine, establishing in that sand that was used to fill the void space. Establishment of shrubs and other vegetation on the upper dune slope, that's going really well. Actually, the higher water levels seem to help that. It's a lot more dense vegetation than we had even thought was going to be possible in that sort of sandy substrate. But because of the high water levels, it's done really well. Hydraulic dredging was fairly effective way to get that local sediment in that location from the bay pumped over onto our beach. And so that works really well. And future sort of management of this area is also used for navigation. There's a recreational marina there. And so as they need to sort of dredge out a navigation channel regularly, we sort of work with them, and we'll have indicated that they can place this material on the barrier beach to help it sort of get back into the littoral system, help nourish the beach. Some of the challenges, if you're considering hydraulic dredging to nourish your beach or build your beach, even if you're very confident you have mostly sands, you really have to be sure if there's any cobbles present. Even less than 1% of cobbles present in that sand is going to put your equipment down. We learned that the hard way. Our contractors undersized the equipment, and unfortunately, they had a lot of downtime fishing cobbles out of their system. And ultimately, we had to mobilize some larger equipment. So if you're in an area of pure sand, you could probably get away with a pretty small piece of equipment. But if you're in an area where you think you have any cobbles at all, you're going to want something that can handle those cobbles. So, and if you're just doing soil probes, you might not pick those up. You really need to be doing some test pitting to try to figure out if cobbles are present in your borrow area. Okay, real quickly, I'm going to just highlight some of the other things. So in addition to protecting Braddock Bay, reducing the wave energy entering Braddock Bay, we've seen an associated increase in the clarity in in water clarity within the bay and an increase in water quality. That's because there's less mixing of sediments, especially phosphorus-rich sediments in the bay. We've seen expansion of submerged aquatic vegetation. Because we've reduced wave energy, it created the opportunity where we could recreate some emergent wetland. And we did this by similar methods that have been proposed in some of the previous slides, but by creating a low stone retaining wall and then filling it with some of the material we hydraulically dredged from the mouth of the bay. And we did that to establish a mix of submerged aquatic vegetation zones, emergent zones, and sedge meadow zones. Lastly, I just want to touch on the channeling and potholing. So this method basically just included getting excavators out into the marsh, which was very uniform, very monotypic, very equal elevations dominated by cattail, and creating some diversity, hydraulic diversity, topographic diversity. And so we did this by excavating about 12,000 feet of channels and about 7 acres of potholes. We did this with the goal of trying to create a diverse network that also connect back to existing sedge meadow areas. We created both large potholes, small potholes, isolated potholes that fish couldn't get into, potholes with islands, and we also tried to excavate these in a way that would maintain their sort of topographic, their depth variability. So we had shallow benches along the edges, step down to deeper elevations, step down to the deepest elevations in the center. And the goal of that was, as Ralph talked about earlier, was to try to get more emergent vegetation established so that when we do get lower water levels, there's a higher chance that we have, a band of exposed substrate that is at the right depth for that emergent vegetation to really get established. And our results are pretty positive. We've seen an increase in the quality, in diversity of wetland vegetation present within the marsh in our restored areas when we compare them to the control areas. We did this by measuring Floristic Quality Assessment Index. A lot of this more recent work has been done here by SUNY Brockport, but it basically showed that the Floristic Quality Assessment Index and the mean coefficients of conservatism of the species present increased it in the channel, in transects running through the channel and pothole areas. In short, what that means is there's a higher diversity of plants, and the plants present are those more affinity, the plants present are those that are associated more with natural habitats rather than disturbed ones. And so that's positive. We haven't seen as much emergent establishment as we'd like, although, we've had sort of high water level years since this work was done in 2016. This past year was the first year through the growing season where water levels were below average. So we're hoping to see more emergent zone establishment in the future, but overall, we are seeing a higher diversity of species, higher diversity of wetland habitats within our restored areas. And right after those were completed, we were able to catch young of the year northern pike in our channels and potholes. So again, this methodology seems to hold up, that if you excavate these things and provide this habitat, northern pike will get in there and spawn. And we've caught northern pike in there consistently every year after restoration. So it's pretty good evidence that the pike are getting up there to spawn. Real quick, some lessons learned just from the channeling and potholing is that this methodology did seem effective at creating habitat diversity, creating vegetative diversity. The cattails have been fairly resilient to infiltration. We excavated them about 8 feet wide and 3 feet deep, rather the channels, 8 feet wide, 3 feet deep. And they've been fairly resilient to cattails moving back in. However, we have had some challenges with floating off chunks of cattail sort of clogging up some channels. And so we think the overall process of going in there and doing all this excavation is destabilizing to the cattail marsh on the short term. And so you should just plan, if you plan to undertake this type of work, to go in and plan for in year 3 or 4 or 5, getting back in there and removing some of these plugs. Because although some of them work their way out, some of these larger sort of chunks of cattail have reached pinch points that are now blocking up some channels. And we think they could actually be blocking up the whole channel column, which might be limiting access to some of our fish species. So as a sort of planned adaptive management, or depending on where you are, if it could be O&M, ongoing O&M, you know, the consideration that after you dig these things, you want to go back in there and make sure, you know, a chunk of cattail hasn't broken off from somewhere after being destabilized and just sort of blocked up your channel. So with that, I'll end there. Again, I hope these techniques have been helpful for you. I'm really glad for the opportunity to share these techniques, and hopefully they've been helpful. I'm more than happy to talk about these with anybody. So here's my email address if you want to discuss this or you want more information about the work done. So thank you very much. Really happy to be part of this this symposium here. Thanks.
Thank you so much, Josh, for the great presentation and for giving us a window into all of the great work that's happening south of the border. My apologies again for going over time, but if we can now invite our speakers to join us for a final discussion, that would be much appreciated. Let's start with Pete and Josh, because we didn't have a Q&A at the end. Steve is wondering if sand nourishment from offshore sand supplies is a feasible option for restoring barrier landforms. Pete, did you want to go first?
Sure. Well, I think it certainly requires some investigation, but I think in short, yes. I touched on a couple places, but on Lake Erie, the tip of Point Pelee National Park, the Long Point tip, and in fact, we found potentially some resources offshore of Rondo as well that might be an option. So this is really new territory for us on the Canadian side of the Great Lakes. You'd have to do the appropriate scientific work to really vet those offshore deposits, make sure that you're not affecting habitat in a negative way and that you're not going to affect the shoreline by removing them. But I do think it's something we need to start looking at more of, for sure, in Great Lakes.
Thanks, Pete. And I see Ralph wants to jump in, but we'll go to Josh first.
No, I think that's an option. I think, you know, at the Braddock Bay project, you know, we did look at the opportunity to use just use a bunch of dredge material, sand, local sand, to try to rebuild the barrier beach. And, you know, depending on, I think, your orientation and other geomorphology, I think different locations, it may be more or less sort of sustainable. So, you know, at Braddock Bay, we found that it wouldn't have a very long project life, that a lot of that sand that was placed to rebuild that barrier beach would just sort of get eroded really quickly, right, with the high wave energy. And at that location, it didn't work well with some of the other uses. That area is used for navigation, and we thought it would, you know, one of our constraints was we could not make the navigation into and out of that harbor any more difficult. And we thought by putting a lot of sand there, it would, if it was unconstrained. But I think in a lot of areas, it makes a lot of sense. I think it's a good approach.
Thanks, Josh. And Ralph?
I just wanted to add, I know in Toronto area, we have a few projects where the sand deposits are impacting navigation and have developed programs where that sand is used for habitat work, but then it is also part of a longer term beach nourishment program where instead of dredging that material off, it can be side cast or hydraulically dredged into those prime areas as a regular annual addition.
That's great, Ralph. Thank you for jumping in. And I see a question from Naomi that you might want to chime in on, Ralph, is whether dredged material is analyzed for contaminants prior to using it to nourish beaches.
In our cases, yes, it does need to pass all the guidelines. And in most cases, the natural scenarios, they are, it's pretty well clean sand that moves along the shoreline. In some cases, they're in closer to the harbor where it has potentially petrochemical additions because of just ship traffic, then it doesn't meet the requirements.
Thanks, Ralph. And another question for Josh is, Neil is wondering whether the budget and materials used for the Braddock Bay restoration are available for reference. And related to that is, what type of stone did you decide on for the terminal groins or headland breakwater?
Yeah, sure. I could give the approximate cost of that project was about $10 million. So in Peter's presentation, his estimate for what similar work would cost, it was 10 million US dollars at Braddock Bay. That was about it. So it's it's an expensive option, but I think it has to be considered in some areas. Type of stone we used large 3-foot diameter dolomite from some of the quarries. We try to source that stone as efficiently as possible. But generally, as a rule of thumb, for the conditions where we are, my coastal engineers say 3 feet is really the size you need to be resilient to ice, to mainly ice forces. If you just had the wave forces, it might be a little less, but with the ice forces and the movement and the shoving, that's about what we aimed for. So our structure was 3-foot diameter dolomite boulders.
Thanks, Josh. And Neil, I hope that answers your question. And I'd now like to open it up to everyone for a lightning round of question is from Erica from actually session 2 yesterday. What is the best way to prevent wetland loss? And as Mary asked earlier in the session or shared with us, there is currently a designated provincially significant wetland in Ontario with species at risk habitat that is slated to be destroyed. So with this happening across Ontario, what is the best way to prevent wetland loss? And perhaps we can start with Pete.
Okay, well, that's I think there's going to be a lot of answers there, but I from what I presented, I think that's what I'll talk about, and really it comes down to looking at our shorelines and the Great Lakes as a system and manage them accordingly, and managing them together. I think we've created all these compartments, we've pulled it all apart, and the reality is it's just one integrated physical, environmental, ecological, economic system, and yet we don't manage it that way. And so when we do, I think if we do, we're going to recognize how important these systems are for all the services they provide, and then we'll also be able to manage them together.
That's great. Thanks, Pete. And let's go next to the CA perspective or Conservation Authority perspective. Ralph, did you want to go first?
Oh, sure, thanks. Yeah, big tricky question. I mean, in a coastal session here, at least in our area, the greatest impact to coastal wetlands is edge development, setbacks, and lake levels, really the water levels. I think I saw the question, it's maybe a little more general around wetlands that, I think protecting most of our wetlands are lost on the landscape as a result of development or past agricultural processes. And I think truthfully, I don't want to say anything to inappropriate, but even the wetland classification system, if you're not a provincially significant wetland, then it's those loss of little wetlands every day that really is the biggest account collectively for one of the biggest losses across the landscape.
Thank you, Ralph. And Paul?
Yeah, just to add, I guess, to what Peter and Ralph have already covered, I think I would also go back to that concept of looking at their management in the watershed context, in addition to the coastal system for some of these, some of the features that we have on our shoreline.
Thanks, Paul. And from a rural context, Laura, what is the best way to prevent wetland loss and coastal wetland loss on rural farmlands?
I think that in this era of more rapid impacts from climate change, that there's an opportunity to show the value of keeping wetlands, restoring wetlands on agricultural land. Even if we do have regulation, unless you're willing to enforce it, it's not effective. So I think it's really, programs like ALICE work with farmers and ranchers to help them protect by enhancing their natural features and wetlands. And restore them. So I think it's an ongoing conversation, but a carrot rather than a stick is the way, if we're really geared towards long-term success, that we need to be doing that.
Thanks, Laura. And from a federal perspective then, Greg?
If people were paying attention to a couple of the slides that were presented over the last couple of days, one in particular that showed the Great Lakes Basin and just the distribution of coastal wetlands, some very large that are visible on the map that I had shown, some showing up as very, very small dots. And in fact, a lot of the coastal wetlands out there are small. They're, a couple of hectares. We tend to lose sight of those coastal wetlands. So one of the ways in which we can just pay attention a little bit more is to track. We are doing a baseline habitat survey, and that's helpful, but we have to do a change point detection over time just to make sure that we're not losing these wetlands. That's monitoring and tracking, but really protection, I think, is really key here. We have a plethora of legislation and acts, and as Pete said, they tend to operate in isolation of one another. So there's always advancements that can be made there. It's much less expensive to protect a wetland than to restore it. So yeah, protection is very much key. Water quality, I mean, we've heard today that without proper water quality, we will have degraded wetlands, and that water quality improvement has to be done at a proper scale, including the catchment, the watershed, and the nearshore transport processes that Pete talked of as well. So I think if people pay attention from today's presentations over the next 2 days, you'll get your answer just through this resilience work that we put together.
Thanks, Greg. And Josh, do you have any effective ways of preventing wetland loss in your context?
That's a really tough question. A lot of good answers being given already, but I guess all I'd ask for it is I think it really takes investment. I think conservation and restoration is not cheap. I think we always, we try to justify these things. We show their, some of the benefits to society, sometimes in dollars, but I think we should also we just need to be aware that sometimes it's the intrinsic value itself that is worth the investment. And I think that's the challenge to wetland restoration. That's a challenge to conservation, is that investment in those things is expensive, but I think we need more of it.
That's great. Wonderful answers all around the table. Our next question is from Ryan for Ralph and Paul. Do you know if wetland restoration interventions are resulting in or have good potential for overall gains, or are other stressors such as climate and development outstripping restoration efforts? So I think the question is getting at, are the restoration resulting in actual gains, and how do we know that they are resulting in adaptation benefits? So perhaps we'll turn to Ralph first.
Well, definitely, I would say yes, they are resulting in gains. We've seen quite a variety of major losses, at least at the historical wetlands on the Toronto waterfront. So we actually see a net increase with the work that has gone on, because at least the remaining wetlands are fairly well protected. And definitely we are seeing positive changes in the areas beyond just the wetlands. Just anecdotally, things like more frequent cases of otters and better fish communities and things that would imply that overall across our jurisdiction, the coastal wetlands are going in a positive direction, at least with some of the new large scale additions. But trust me, they're still very degraded in many of our river mouths.
Thanks, Ralph. And Paul?
Our jurisdiction is much smaller than Ralph's, so the gains, like projects like Jim Tovey Lakeview, are excellent and represent a gain. On the whole, I think they will be a little more, the coastal opportunities will be maybe a bit more difficult for my authority to realize, and I would even extend that to the watershed as a whole. Often what we're finding, we're working is in already regulated areas, and restoring wetlands from certain impairments, whatever they may be. On private land in particular, gains of any sort, whether they be stream or wetland, are very difficult to engage with from a stewardship perspective, because we're potentially drawing a new line on someone's property, and so that takes a very special and willing landowner, and we have done that. But gains as a whole, I find to be more challenging. That's often I find myself in positions of restoring impairments.
That's great. Thanks, Paul. And another lightning question for all of you is starting with Pete, is how, if you can give us an example of how you're integrating climate change into your work, into your restoration work or other work that you do. How are you factoring climate change into that?
Okay, well, first of all, we're using the projections from Frank's work that you heard about on Monday. We are looking at historical changes in ice cover, and we're just in the process now of doing some wave hindcasting work that's going to look at a zero ice cover scenario on Lake Huron. So I think that we need to understand that fence post as to what it's going to mean when we have no more ice in the Great Lakes. So that's being integrated. And the other piece that we're doing is looking at changes in recession rates. So shorelines erode all over the Great Lakes. It's natural, and the best thinking we have right now suggests they're going to erode faster, and that just is a call to action, really, that these challenges we face already are going to get worse. Some things haven't been looked at yet very much, and that's the movement of sediment during ice-free lakes. So how does the sediment delivery system work in the Great Lakes, the littoral cells, the back and forth of sand and gravel? That's really not been touched yet at all, at least on the Canadian side. So that's an area of more work. So, but it's being, everything we do is being pushed through that lens now, risk assessments, because it's absolutely critical that we take a look at what these future projections are going to mean for the physical system.
Thanks, Pete. Always insightful. Ralph and Paul, from a Conservation Authority perspective, are you integrating climate change into your restoration projects?
Yeah, Lakeview was a good example, I think, where that was looked at through the modeling exercise at the National Council of Canada, modeling different lake level scenarios and different sorts of storm events to inform that type of creation. So yeah, it's definitely top of mind.
Thanks, Paul.
Yeah, and from our side, we would, I mean, we're pursuing every avenue. I mean, we have a climate change working group here at TRCA, and we're always looking at appropriate plant species, you know, part of the resiliency work, looking at lake levels and staying in tune with emerging invasives. So yes, definitely. I think if everyone could tell us exactly what's going to happen, then we'd be way better off. But you know, we're trying to. It does pervade every decision we make.
Thanks, Ralph. And Josh, do you care to share with us how climate change is factoring into your work or the work of the U.S. Army Corps of Engineers?
Yes, absolutely. So yeah, it's part of our policy as a federal agency to consider that, to consider resiliency, and at the core for our projects, primarily what we do is we try to consider future scenarios. So we sort of have based on our information, what we anticipate to happen, and then we try to consider how resilient it will be under sort of a higher water level scenario or a lower water level scenario. And, you know, depending on the project and the complexity, so, you know, that may be a qualitative or quantitative, you know, modeled assessment. But, you know, even if it's simplest form, it's assessment to say, well, if the lake's a couple feet higher, we still think this is going to function as designed. When it's not going to be, you know, a loss, or if it's a lot shallower, this is what's going to happen. So yeah, all our studies, we try to consider that and factor that in.
That's great. Thanks, Josh. Laura, did you have anything that you'd like to add as well? Any examples from your work?
Yeah, so at a totally different perspective. So because our communities are, you know, doing different project types, they share information about what's working and what not, and what isn't working. So just as an example, a lot of our Western communities were finding that tree planting, the trees just weren't surviving. So they've taken on assisted natural revegetation rather than tree planting. So, information is shared between the different community programs about, what's better likely to succeed with climate change. We're also working to integrate natural infrastructure into some of our municipal partners' planning and financing in Western Canada. So we've got climate change really pervades all of the work that we do now. It's not something that we add on to, but it's, part of building resiliency and seeking funds for nature-based solutions and pretty much everything that we're doing.
Thank you so much, Lauren, for everyone for your answers and responses. Very helpful and insightful. I think cognizant of our time, we will leave the last question to, our guest, I believe, joining us furthest away. So Josh, with the federal administration's focus on infrastructure investment, is there any new funding or policies that you're most excited about?
Yeah, so there's been quite a bit of investment in infrastructure, and even prior to that, though, the Great Lakes Restoration Initiative, I'm just going to highlight that's been phenomenal at putting money towards restoring the Great Lakes on the U.S. side. And there's a lot of projects, a few of which I've been lucky enough to be involved in. That's been really a great opportunity. So GLRI still going on, that funding's still going on. Hopefully we get more, keep it coming, and we can do good things. So
wonderful. Thanks, Josh. And hopefully that sparks some ideas for our grant funding organizations as well on the Canadian side. And with that, that brings us to the end of our discussion panel. Thank you again to all of our speakers for excellent presentations today and for your ongoing work and for staying with us over time. I would also like to thank our project team, Greg, Anders, and Patrick from ECCC, and Megan, Jessica, and Krista from TRCA for making this webinar possible. For questions that we were not able to cover within our time today, we will follow up with speakers for some brief written responses, which we will share along with the presentation slides and webinar recording. We anticipate that the slides and recording will be available in a couple of weeks following the webinar series, so please keep an eye out for an email. We have 2 more webinars this week where we will continue our focus on possible adaptation strategies and options for enhancing coastal wetland resilience. Tomorrow's session will focus on ways to cope with lake level extremes, manage dike wetlands, and restore biodiversity, including management of invasive species. And we have an exciting lineup of speakers for tomorrow with 6 sets of guest presentations. So we hope that you can join us tomorrow for these exciting talks. I would now like to call on Greg to say a few last words and share some upcoming reports and resources.
Thanks, Sharon. I will not take very much time. Thank you for sticking with us. We went way over time, but wow, it was so worth it. Thanks to our speakers today. I promised our audience that we would bring to life our adaptation strategies, measures, and options, and you speakers did a fabulous job of doing that. So thank you so much. I truly appreciate it. I've already mentioned a number of reports coming out from this study. Here they are once again on the screen in front of you. The one that we had discussed today, Adapting to Climate Change, Solutions to Enhance Great Lakes Coastal Wetlands, is yet another edition of several reports that we will make available to the public. They will be made available as a package and published on our website once they go through a lengthy communication process. So thank you for sticking with us today. Thanks to our speakers. So thank you so much.